Good morning, everyone, and welcome to our first Consul Adoption Day. So this one's going to be a little bit different than our other webinars. We're joined by 6 different speakers today who are going to cover a range of different topics on Consul, everything from service discovery to service mesh. The session is being recorded, and we're going to be breaking it up into each of the 6 individual sessions and posting each of those videos to our website after post-processing. It's going to take us about a week to be able to gather everything. Throughout the sessions, Q&A is going to be done at the end with part of a live panel discussion. Except for our first panelist, who we're going to do a live Q&A session at the end of his piece. And so throughout the different sessions as you're watching, make sure you're entering your Q&A into the chat box. We'll be gathering those and answering at the end. If you can't stay for the entire session, just make sure you come back at the end where we'll be answering those questions live, but we'll also be following up with our questions afterwards. So for our first speaker, I'm very excited to introduce our first guest. We have Sriram Govindarajan. He is a principal infrastructure engineer at Mercedes-Benz, and he is going to be talking about how him and the Mercedes team have been using Consul for service discovery. So with that, to kick us off, I'm going to turn it over to Sriram.
Thank you so much, Peter. Appreciate it. Let me see if I can share my screen here. All right, so I guess my screen is shared. People can hear me, so let me go ahead and start with it. All right, thanks everyone for taking time to get to this webinar. Appreciate it. HashiCorp, thank you so much for inviting me to speak at this event. Truly appreciate that. That said, let me start with this. All right. I'm just going to give a very brief overview of what MBRDNA is. I will tell you very briefly what we do. I'll give a high-level architecture overview of where we are and why do we need service discovery and why we went with Hashi's Consul. I will slightly dig in a little deeper about our Daimler Consul architecture, just so it gives us an idea of why we have implemented the way we have implemented it. I'm not going to go into in depth on service mesh, but I will just briefly touch on it because I just want to let people know, what the future is in MBRDNA and stuff. All right, so that said, that's a very brief introduction of what MBRDNA is. MBRDNA is a Mercedes-Benz Research and Development North America. Once again, thanks everyone for making it to this. My name is Sriram Govindarajan. I am a principal engineer at MBRDNA Seattle. Let's see what we do at MBRDNA Seattle. MBRDNA Seattle Hub is a connected car division within MBRDNA. We are sort of like I put on a slide, we are the digital accelerator for Daimler. What that means is, in our existing generation of Daimler backend services, everything is in a data center architecture. So the main focus of our hub that was formed, I want to say about 2.5 years back, is sort of like make a nice, good developer productivity platform for people and move into cloud. Not for the sake of moving into cloud, but the idea is, the engineering teams can get new and exciting features fast and easy into what we call the Mercedes Intelligent Cloud. The idea is, with the current data center architecture, I'm not going to go into the details of what's difficult or what's wrong with it or anything of that sort. It's just that there are a lot of pain points there, and we want to address that with our new cloud architecture. The whole idea here is engineering teams themselves decide as to what goes in and when, right? We follow a lot of agile methodology. We evangelize DevOps culture within the company. What that means is, if I'm the engineering team, I not only own the source code of my services, but I own end-to-end ownership. What that means is, starting with the source code, I own the CI/CD process, continuous integration, continuous delivery, deployment. If my team is mature enough, there is nothing that's stopping me from going in for a continuous deployment, meaning like every single commit that I do, I can push it to production. Well, the whole idea is that, right? End-to-end ownership. So source code, CI/CD, deployment, what else? Maintenance, infrastructure, security, everything that goes along with it, right? I mean, the engineering team would own it. We're empowering the teams to go with it. Of course, there are a lot of experts from different walks of life in our hub here, as well as around Daimler. We help teams with a lot of best practice suggestions, and then of course they're welcome to talk to us in terms of their architecture, how they want to do things, etc., etc. But the whole idea is, we have formed a big community of developers around, where we share a bunch of do's and don'ts, or let me put it this way, we share a lot of learnings that came across from different teams, good and bad, so that people benefit from both good and bad, that the teams have done. What else I wanted to say? Yeah, like I said, the hub is about 85 people now. It was started about 2.5 years back. We do a lot of nice, good, cool projects. There is a lot of exciting new technologies that we get to work on. Of course, needless to say, MBRDNA is hiring. Please do check out MBRDNA careers, or reach out to me. I will put you folks in touch with the right people. Or if you ever want to talk about, what is it that we do, or have additional details and things like that, I will be super glad to have a conversation with any of you. All right. So with that introduction, let's get into a very high-level architecture of how things work out. Like I said, right, the whole idea of moving into cloud is not for the sake of moving into cloud, but make it a developer productivity platform. What that means is, if I'm the developer or I'm the engineering team, I want an easy and a reliable process to push my changes into production as soon as possible, right? I mean, that's the whole idea of making a developer productivity platform in the cloud. Of course, this diagram here that I have sort of like oversimplified it, but the idea here is, with all millions and millions of cars running on the roads and around the world, any of the backend services, that means, anything that the car wants details on, that's a backend service. All those backend services are running on a cloud today. Like I said, the previous generation, everything was running on or a data center architecture, but I think we have done a reasonable job in the past couple of years, in terms of moving from the data center architecture into cloud. I don't know the exact details of where we are with regard to the migration, but I want to say we are like very close to moving everything out of data center into cloud. That includes all regions. We have one for Americas, one in Europe, and then one in China. All right. So that said, any request that comes from a car is going to go hit what we call a geo tier. A geo tier is nothing but a giant VNet. Sort of like, think of it as like shared services VNet. That's all it is. A bunch of shared services that everybody needs is going to be in the geo tier. That's what is on that. I put Consul there, but I'm not going to go into the details of it now, but I have another slide, where we will talk a little bit more detail of what's what. Underneath geo tier, you're going to see a lot of environment tiers. I will go into details of what an environment is and such, but before that, I will tell you why we have multiple environments there and what is the connectivity between geo and environment, right? So let's talk about what the connectivity between geo and environment. Geo tier and environment tiers are VNet peered. So that means if I have an environment, every environment that I create is peered into the geo. That means there is connectivity between the two tiers. So if I have a service running on, let's say, one of the environments, I can easily talk to anything that is running on geo VNet, because there is network connectivity there. That said, let's talk about why we have multiple environments there, right? Remember, I mentioned earlier, that we were shooting for an end-to-end ownership of model for individual teams. What that means is we do not have a central operations team, right? To sort of like in let me put it this way, in kind of like old school or in other different companies that I've been part of, there used to be a central team that is responsible for not just operations, but for everything. Like sort of like everything has to pass through the central team before getting into production. That's good and bad with it. I'm not going to go into the details of it, but the idea is, in MBRDNA or in the current architecture that we're working on, we did not go with that model for various reasons. That's why we were big proponents of like end-to-end ownership. What that also means is, if we say the teams are going to be owning their environments, we should also provide a way for safeguarding the teams, in the sense, that I don't want another team to inadvertently mess with the configurations of my team, right? I mean, that is one of the criteria. In order to satisfy that is the reason why we went for this multiple separate dedicated environments for different teams. One of the reasons, there are multiple other reasons, but one of the reasons is that, right? So that means if I'm an engineering team, I will be given my own dedicated environment. What I do with it is completely up to me. Of course, I can refer to best practice recommendation. I can involve experts as and when I see fit. But the whole idea is I am responsible for the team. The engineering team makes calls in terms of what goes in that environment, what gets exposed, what are the different security aspects of it, what are the CI/CD portions that I follow to get things deployed, etc., etc. The whole thing lies with the team. That said, let's talk a little bit about what those environments are, right? Kubernetes was our platform of choice, that we chose for various reasons. There's a lot of goodness in Kubernetes. Of course, there's a lot of complexities as well, but majority of the people, wanted to go with Kubernetes. And of course, a lot of people in our previous lives have used Kubernetes, so we felt, this will be like a good solution for some of the things that we do there. So that said, we did not want to have like one Kubernetes cluster shared by multiple people, because people were worried about how things are going to work, who's responsible for maintenance, like operations, how will the cluster get upgraded, etc., right? So in order to avoid all this, we started providing teams their individual Kubernetes clusters. When we went that route, we realized, kind of like having this manual process is going to be a painful thing. And of course, we didn't want to give complete control of creation of those Kubernetes clusters to the teams because of simple problems like, network overlap and things like that, right? So our infrastructure engineering teams own the network. So they kind of know, like who's got different subnets, and they handle things like, like how to make sure, there is no network overlap and things like that, right? As part of this effort, what we did was we created a self-service portal wherein teams can go fill in a bunch of details, hit submit, half an hour, 45 minutes later, they're going to get their own Kubernetes cluster. And what they do with it is completely up to them, right? So we started doing it, because for various reasons, right? We said DevOps, we said infrastructure as code, automation, all those things, right? So once we put this process in place, as you can imagine, several people went ahead and created clusters the way they wanted it. And pretty soon we had like hundreds of clusters, right? It's good and bad. There is cost factor, but there is also no operations one, right? The teams are responsible for it, and then they were doing it. But what also ended up happening was, there are like multiple different clusters and different services running on them. So I'm just going to leave it at that, and I will pick it up later as to why we needed a service discovery, why we decided to use Consul and things like that. But just to sum it up, the whole idea is we have a geo tier VNet, and then we have environment tier VNets, which are paired with each other. Each and every environment is its own dedicated Kubernetes cluster. And we're using Azure for our public cloud offering. And we decided to use Azure's managed service, which is for Kubernetes. Azure Kubernetes Service, AKS, is what is our offering. All right, that said, now comes the question of why we need service discovery, right? I'm just going to go back to this slide very quickly because this is where I mentioned, each of these environments that I'm pointing out are separate Kubernetes services. AKS1, AKS2, AKS3, or cluster A, cluster B, cluster C, right, in its own dedicated environment. Now, think about if let's say if I had one giant Kubernetes cluster, right, and then I had deployed all my services into it. I'm going to make use of Kubernetes inherent service discovery feature to get things done. In technicality, I don't need a service discovery feature for that, right? Because Kubernetes provides inherently, I can use it. But in our case, that's not the situation, right? We have multiple Kubernetes clusters. That means I need to know where what service is running. So, which is where necessitates the need for service discovery, right? So we needed a single source of truth for where what is running, so that has become a paramount for our infrastructure. So multiple clusters, different running, different services, and some people run like, I don't know, 2 or 3 services in one cluster, or some people have like the idea of application groups where they run all the related services in a particular cluster. It goes by, the teams, right? But the idea here is multiple individual clusters running different services, and we definitely need a single source of truth to sort of like maintain the state as to where what is running. Of course, it's Kubernetes. The pods are going to get restarted, to maintain the desired state, et cetera, et cetera. So that means we wanted the single source of truth system to kind of hold the exact state of those services. Say, for example, if I have deployed a service, and then the pod gets restarted, I'm going to get a new IP. Say, for example, cluster IP. I want the new cluster IP showing on my single source of truth, right? So that is one of the main requirements for us, for having a nice, good service discovery solution. What else? That's what necessitated the need for service discovery. Like I said, multiple individual clusters running its own services. Some services are dependent. So we needed a single source of truth to tell us where what is running. Now, the question comes to as to why we went for HashiCorp's Consul for service, right? For people that have already used Consul, this is kind of like a no-brainer, right? I mean, a lot of us in our hub have used Consul in our previous lives. So Consul is like a synonym for service discovery for us, right? I mean, that's what we've used in our previous jobs, so we were like, hey, the moment we started talking about like a cloud native service discovery solution, we were like, yep, let's go with Consul, right? It was super simple for us. But of course, we had to try and evaluate various other tools that are available, to show that, we have done sort of like a comparative study and such. So we started investigating into Zookeeper. I have not used Zookeeper in my previous jobs and such, so we started looking into Zookeeper, but then we quickly realized, that, man, there is too much of additional things that need to be done if we end up going with Zookeeper route, while Consul provides a lot of things, out of the box. So why not go ahead and use it? So it was a simple decision for us. It started out as a POC effort. We went into Consul, we decided, quickly that Consul is the way to go, and we were going to end up using Consul for it. Just to give you guys an idea of our data center architecture, we're using like Netflix Eureka model on that, right? So Eureka provides certain service discovery sort of features there, but again, that is not cloud native solution. So we wanted to go for a cloud native solution, and Eureka didn't fit the bill, which is exactly why we went for Consul, which is, like I said, synonymous to service discovery, right? Of course, Daimler is huge, and we have several teams distributed geographically, around the world, right? So we wanted a solution, that provides us good reliable enterprise support, right? Again, Hashi fits the bill. Again, this comes out of a lot of us in the hub, that have used this product before, who have good relations with Hashi. And we've seen, how Hashi support works, et cetera, right? Based on all those, we decided to go with HashiCorp's Consul. Personally, for me, the best portion about Hashi tools in general, not just Consul, Hashi tools is, what I like best about them is the simplicity, right? I mean, Hashi tools are sort of like thin client. They're not like super heavy. They pack nice good features, but they try to keep it sort of like thin, right? I mean, it's not like heavily overloaded or anything of that sort. It makes your life easy. The maintenance on them is like super simple. So I would that's been my experience with Hashi tools, be it Terraform or Consul or Vault or anything such, any of those things, right? So that was again another reason that factored into Hashi's Consul that we ended up using. All right, so that said, now I want to dig a slightly little deeper into our Daimler Consul architecture, right? Like I mentioned earlier, remember there is a geo tier and then an environment tier. They are paired with each other, so there is network connectivity. So what do we have in our geo VNet? What we did was we created an AKS cluster, Azure Kubernetes Service Cluster at the geo level, and then we installed Consul servers on those clusters, right? So so in this case, it shows like 5 pods, if I can say, 5 pods of Consul server installed, which form like a quorum and stuff. They elect a leader and all that. Again, I'm not going to go into the details of it, but the idea is Consul server cluster is installed at the geo level, and then at the environment level, we have Consul clients installed, and each of those clients are installed as daemon sets. What that means is every single node in a client cluster is going to have a Consul client, right? And then the Consul clients are joined to Consul server cluster, making them a huge, giant, happy Consul family, right? I mean, they do their gossip, they have their Raft protocol, all the goodness about Consul. I'm not going to go into the details, but that's how we form a big, giant Consul cluster. Consul clients at the environment talking to joined to Consul servers at the geo tier. Once Consul clients are joined to Consul server, right, then suddenly this cluster becomes Consul aware. What that means is, I can just as easily do a DNS resolution and get to my services. Now, let's take a use case. Say for example, I have deployed service A in cluster A, service B in cluster B, service C in cluster C. Let's say for argument's sake, all these three services are owned by separate engineering teams, not the same team, separate engineering teams, right? And just to complicate the scenario, let's say there is dependency, just like any other enterprise will have. Let's say there is a dependency. Service A depends on service B, and then service B depends on service C. So let's say if we have such a dependency scenario. So environment A having service A, environment B having service B, environment C having service C. A depends on B, B depends on C. Let's say if that is our scenario, right? What ends up happening in this case is service A has got its own independent lifecycle. So the engineering team A, which owns service A, is going to be busy with their feature development, blah, 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 and then they're going to deploy their services on environment A, right? Likewise for service B and service C. Now, what happens with the dependency? So let's say service A can only be fully functional if it finds service B, right? In that case, what needs to happen is service A needs to know where service B is running. Now imagine life without this Consul server cluster, or imagine life without Consul. There is no way for me to know where this service is running unless I maintain this list, unless I sort of like have my own custom solution to maintain all this list, and then I worry about, how to keep it updated, etc. Right? So it gets super difficult, and imagine there are like about 200 plus services that we have, and the number is only growing. So it was impossible to keep track of what's what. So now with Consul, what happens is service A just makes a call to Consul and then says, hey, Consul, tell me where service B is. Consul gives back the IP address of wherever the service is running, and then service A can talk to service B because there is network connectivity. Remember we spoke about VNet peering, environment peered to geo in turn peered to, geo in turn peered to other environments. So with that, there is network connectivity, and that's how services can talk with each other. Service A talks to Consul, says, hey, tell me where service B is. Consul returns the address, it makes a call to service B, right? And then service B is like, it's got dependency on C, same way. Service B talks to Consul and then says, hey, where do you have service C running? It tells you where it is running, and then it returns the IP, and then that's how they talk to each other, right? Now, I said IP, it depends on how you have implemented it, right? So in each of these clusters, a lot of teams have implemented internal ingress. If the service that they want exposed is only within the clusters, like the case with the many enterprises, I would assume. So you can return an internal ingress, or it can return a cluster IP. I'm like, hey, my service is too small. I don't want to bother with internal ingress, etc. So I just want to expose my service as a cluster IP. So anybody that's got access into the cluster, into our environment, or rather into our, how do I put it, into our, what we call it, like Mercedes Intelligent Cloud, into our cloud environment, then they can they can easily get to the services. So it depends on how I have exposed my service. Some people have exposed it as cluster IP, which gets registered into Consul. Some people have exposed it as internal ingress, which gets registered into Consul. And then once you make a call to internal ingress, the ingress rules tells you where the service is running inside the cluster, etc. What else I wanted to say? So that's the whole idea of it, right? So Consul makes a call, or rather, the service makes a call to Consul. Consul client talks to server, and then it gives you what is running, and then that's how they make the call. What else? Let me make sure I've not been talking too long and I have enough time. All right. So that's pretty much what we have in terms of our architecture. I'm not going to go into details of it. I will leave some time for questions. And the last slide I have is about service mesh. We've not done much in terms of service mesh, but the only reason I put this slide is because, that's the future. That's exactly what we're going to explore next with regard to Consul. Because our initial idea was to move things from data center into cloud. And there was already a steep learning curve for people. One is getting used to Azure. None of us knew Azure before we came into MBIDNA, so a lot of learning curve for us. That means a lot of learning curve for the dev teams as well. And then a lot of learning curve for Kubernetes for a lot of people. And in general, a lot of learning curve about cloud and the different processes, etc. So on top of it, we didn't want to add yet another layer for service mesh, because in my mind, service mesh is slightly complicated. It involves a little bit more time and effort, to understand how what's done. Of course, we all love the features, but we need to spend a little bit more time. So the primary focus was to get everything moved into cloud, and then, start implementing features incrementally, right? So I think it's safe to say that, we are at a state, where the things have stabilized, things have already migrated into cloud. A lot of things at least are, and teams have come up to speed with regard to, how to operate and a few things like that, right? So now the natural progression is for us to go with the service mesh. I've already seen interest from a lot of teams, that want to proceed in this direction. And of course, as part of our POC, we tried doing Consul Connect, and from our experience, it was fairly simple. Just add like a couple of annotations, and life was, suddenly you have like your proxy talking to other proxy, etc. Right? So I just wanted to say that, that will be our logical progression going on to the next thing. With that said, I will open it up for questions. Please shoot any questions you guys have. Thank you.
Thanks, Sriram. We did have a couple questions come in, so I got some lined up for you. One of the questions that came up was around your VNet peering. Are you just using the Azure native VNet peering?
Yes, absolutely. Absolutely. So like I said, remember I spoke about our self-service portal. As part of that job, what happens is every time a new cluster is created, yes, we, like I said, we own the networking portion, or rather the infrastructure engineering team owns the networking portion, so we know exactly what our IP spacing is going to be and what kind of subnets are going to be created, etc. And then as part of our automation, we do create the peering. That's exactly how it works.
Perfect, thank you. One of the other questions that came in was just asking about, well, it's twofold. So one, could you talk a little bit more, you mentioned it briefly, but maybe go into a little bit more about why you chose Kubernetes versus maybe some other options. And then also, do you have any like social or LinkedIn information that you want to share in case people want to ask you questions?
Sure, yeah. All right. Great question on Kubernetes, right? Of course, Kubernetes is like kind of like the buzzword around the industry, right? Everybody wants to work on Kubernetes. Everybody wants to do things on Kubernetes. So that is one thing. Of course, the other side of that is Kubernetes is incredibly complex. If it is not done right, then it makes your life a little miserable, right? What we did see was, there are Daimler being a huge enterprise, we see both sides of the spectrum. There are some teams and services that need something like Kubernetes because of the nature of their services and the size of the team, etc., where they have the ability to learn and kind of like manage the cluster by themselves. Whereas on the other side of the spectrum, we have smaller teams, who don't have much expertise, and they are forced to handle things on Kubernetes. That is not a very ideal thing, right? Of course, Daimler being Daimler at a big company, we have ways to mitigate this. They can always talk to people like us, who are in the middle, can help them, with some of the processes and such. But yeah, I'm guessing, as part of our next version, there might be some teams who will be like, yes, this is where we want to be. We want to continue with Kubernetes. We want to make it better, start using new features, etc. While there'll be others that might say, that, hey, this is incredibly complex for us, so help us make it simple for us, right? So the way I'm envisioning this to happen is, some teams will want to move to sort of like a shared cluster architecture where there is a central team which operates just the infrastructure portion of Kubernetes while the teams handle their services, while other teams might just go and choose like a different service that's available, right? Maybe, I don't know, Azure container instances or something like that, but we have to wait and watch, in which direction that goes.
Awesome, thank you. So we had a question come in about, so after you discovered that your service is using Consul, how are the daemon sets in the different environments talking to each other?
The daemon sets in different environments are not talking to each other. That's, well, I lied sort of there, because there's of course Consul gossip happening. So I won't, rather taking Consul gossip out of the equation, what happens is your Consul clients are installed as daemon sets into your environments, right? So that daemon set, every Consul client is joined to your Consul server cluster. So your Consul client is only talking to your Consul server, right? So the moment you get, say, for example, you get like nslookup service name dot domain, right? Or service name dot service dot Consul or something like that, right? As soon as you get that request, Consul client is going to take it to the server, and then the server is going to resolve and get the contents back. But then The other portion of it is where the peering and the network connectivity comes in, which ensures that there is a connectivity between the two clusters. And say, for example, I have 10.1 and 10.2 on two different servers, right? And if Consul returns me 10.2 and I'm on 10.1, because of the network connectivity and peering with multiple hops, it can talk to those services.
Perfect, thank you. We have a number of questions coming in, so we may have to follow up afterwards just for timing. But next question that came up is, could you tell us a little bit about the size of the Consul cluster that you're running? Like, give us an idea of the scale.
Sure, yeah. Consul server cluster, I'm going to talk about both, right? Consul server and Consul clients. Consul server cluster is, I want to say it's a 3-node cluster. I mean, it's just like DS3 environments, I think that's what Azure calls them. Not super huge, but we do have like a 3-node cluster where we run the servers. Right now it's 5 pods that we are running. Scaling is not an issue. Of course, we can go for auto scaling or horizontal pod scaling or whatever, right? I mean, Consul supports a bunch of things. But so far, for us, Consul has not been the limitation in terms of, or a bottleneck in terms of resolving services and such. There are multiple ways to mitigate it, right? I mean, we use like time to live, etc. To kind of like get the services. So scaling has not been an issue for us now. And as far as client goes, like I said, it's a daemon set. So if you have like a 3-node cluster, you're going to have 3 Consul clients installed. If it's a 10-node cluster, you're going to have 10 Consul clients installed. Again, this is all automated. We don't have to go look into everything. We have proper alerts and everything set up. So if something fails, we'll get an alert as to what's going on. And if teams can choose to set alerts for Consul clients, and they can verify if there is connectivity, etc.
Awesome. All right, so I'm going to ask the last question here, and then unfortunately we are going to have to move on. But just so folks know, we do have Sriram's story posted on our website with Mercedes-Benz talking a little bit more about how they're using it at the research team. Might answer some of these questions, but we'll also be gathering these and try to answer them for you either in the chat or at the end during the live panel Q&A. And I just want to be respectful of Sriram's time here. So last question is obviously, like, you went Kubernetes. One of the questions came up is, what was the driving motivation for you to use Consul versus something like Istio?
Great question. Istio is an amazing product, right? I mean, Istio has got tons of features, but what that also means is you need a fleet to maintain Istio. You need a rather large team to maintain Istio, right? I mean, at least that's what I've seen out of my experience. And I'm sure a lot of people that have used Istio would agree with me, in that it's good in features, it's feature rich, but the amount of features that you use versus the kind of maintenance and the team size that you need to maintain it is rather large. Like I said, our goal was to avoid having the central team to doing things. So we did not want to have any sort of effort, diverted in that direction, which is what sort of like, pushed us towards Consul. Consul, we have 2 things, right? One is Consul, like I said, it's lightweight, it's super simple. People understand what needs to be done. We have conducted a lot of brown bags and stuff like that internally, so that people come up to speed with why we need service discovery, how to do things with Consul, how to do service discovery resolution with the HTTP APIs or Consul prepared queries, a lot of things like that, right? Second thing is, we also have enterprise support from Hashi, so we kind of like divert a lot of questions that people have to Hashi, so that they're the experts of that product, so they can answer it a lot better than what us like internally can possibly ever handle.
Appreciate it. And again, we'll work on getting some of these other questions answered, but I do want to make sure we're staying somewhat on schedule. Sriram, really appreciate your time. Thank you so much for coming to talk to us. We're going to move on to our next speaker. It's going to be Eric Chen, who's a solution architect from F5. He's going to be talking to us a little bit about BIGIP and how you can use Consul to conduct service discovery with BIGIP.
Thank you, folks.
All right. Thank you, Peter. So as Peter mentioned, I'm from F5, and I will be talking about how to use Consul with the BIGIP. So this is kind of the agenda that we'll be having today, is that we'll just be kind of talking about how all of these pieces are going to work together. And I'm going to be doing a demo as part of this. So, in the previous presentation, we kind of talked about Consul. Because this is going to be provided as separate recordings, I will be kind of repeating some of the material. I'll try to move through it a little bit quicker to kind of explain what Consul is, just to provide context for people who are watching this in the replay. And more importantly, we'll be doing a live demo. So, everyone cross your fingers for me, because this is live demo time and we all kind of know how that goes, right? So moving on, let's kind of set the stage of what we're going to be talking about today. So we heard from the previous presentation kind of how they're using service discovery from a service to service perspective. But what I'm going to be talking about is how we can approach this from an infrastructure perspective, because you may want to have something like a reverse proxy that is going to be able to leverage the information that is stored in Consul and make use of it to secure services, remove that kind of friction that infrastructure teams currently have. So for example, I am coming from the network side of an organization, and for many of my peers that are in kind of more of the development world, you're probably very familiar with having to submit a service request to make a change to an environment. So service discovery is really important, because what I'll be demoing is how do we remove the need to file service tickets? How can we leverage Consul? How can we leverage automation so that when you deploy a service within your environment, your infrastructure reacts to it. It reacts to it as code. So this is really what we're going to be focusing on today. And we'll also be seeing how this works. So as part of the demo, we get to see, we'll see the pieces that were talked about earlier. We'll see Consul in action. We'll see how we're using service discovery within the environment. So now that we kind of know what we'll be talking about during the session, let's look at kind of the different parts that are in here. So I was putting this out there on social media. I don't have a great way to poll, but hopefully this doesn't confuse the panelists. But if you have familiarity with BIGIP, I'm just kind of curious, maybe just raise your hand via the Zoom feature, and we can kind of take a quick look at how many folks here know about the BIGIP. So good chunk of you folks. So that's good. So for the folks who raised your hand, this part will be review. For folks who may not know about BIGIP, I'll just kind of do a very brief kind of review of what it is and how it relates to Consul. And then we'll kind of come back and talk about Consul as well. So thank you for raising your hand. You can put your hands back down. I can still see your hands out there. Okay, it's okay. You can put them down. So now that we kind of have identified who here knows about BIGIP, let's just talk about it briefly. The BIGIP is traditionally known as a load balancer by many folks. So, this is the high availability, disaster recovery type of use cases. And it kind of, our platform can run in many different form factors. So many people know our platform for running in a hardware form factor. So that can be like kind of a pizza-sized box, kind of have big metal for if we're talking about our service provider customers. But we also have a platform that can run as a VM. In the demo that I'm going to be providing later, I am going to be running our reverse proxy in an AWS environment. So we're making use of AWS's hypervisor to host our platform. And this is very important because for many of our F5 customers who are accustomed to using our software in their on-prem environments, there's a lot of comfort to know that if you look at the screen right here, that there are many services that our platform can provide. So beyond what we can provide from a high availability perspective, we can provide many security capabilities. As our customers are deploying into the public cloud, they still want to do things like protect their applications from attacks. So they would want to have our web application firewall. They want to prevent some types of DDoS attacks. So they want to make use of our network firewall capabilities. More recently, there's been a huge upsurge in the need for remote workers, and many people are using our identity solutions for providing remote access and security to applications that they're deploying in the public cloud. So this is just kind of a brief overview of some of the ways that our customers are using a BIGIP in their environments, whether it's in their on-prem or the cloud. And HashiCorp has been critical for making the multi-cloud capabilities of the F5 in terms of automation and deployment. So now that we've kind of talked about what the BIGIP is, let's review what Consul is from a network perspective, because for the folks who are joining who may not be aware of Consul, it's useful to kind of describe how the idea of service discovery could apply to network devices. So again, if we go back to what I was talking about earlier, traditionally we think about when we deploy infrastructure, it's going to be this flow of a developer or application owner having to notify the network team or infrastructure team that a change has to happen. As we can look here, what we're talking about is a way that we can do automatic detections of services that are on the network, right? So what we're going to be looking at is an architecture where our client is going to be our BIGIP device. So we'll kind of see this in a little bit. We're going to be using Consul. So this is going to be replacing that process of where you were previously having to open up a service request and providing that information of where the services are. So what this is going to do is we'll kind of remove that entire process of where you would have to kind of manually tell your network infrastructure operators where to make a change and have Consul propagate that change securely within the environment. So as I mentioned earlier, I will be doing a demo of using Consul. As part of that demo, I'm going to be making use of 2 HashiCorp technologies. So this webinar series is focused on Consul, but HashiCorp coincidentally has a product called Terraform, which can be used for kind of infrastructure automation. I'll be using that, using Terraform as part of the demo, but it will be used to deploy Consul, BIGIP, and Nginx within the environment. And Nginx, coincidentally, is another example of a reverse proxy that can be used for Consul service discovery. But today, we're focused predominantly on the BIGIP. So now that we've kind of looked at BIGIP and Consul, why is it that we've come together on this webinar to talk about the two? And the big part of it is just what I've been saying earlier. When we've surveyed our customers, they say that the network team is the bottleneck, that they're the ones that are slowing down the deployment of your applications. And working with HashiCorp, working with Consul, we are removing that bottleneck so that as you're deploying your applications into your on-prem or your cloud environments, they're getting out much, much faster. So that is a huge win for our customer. And then the other part of this is that when we're doing it in an automated fashion, we're reducing the risk of a failure. So if you think about traditional ITIL process, you go through a change advisory board, you have a change window, that it just doesn't work if you're working in a highly dynamic ephemeral. Later on in the sessions, we're going to be talking about service mesh and just kind of how dynamic service meshes are, and that's where it really would break down further. But the main goal is that when we're making use of HashiCorp and F5 technologies, is we're reducing the risk for our customers in being able to securely deploy their applications. And then the third aspect of this is that in this particular demo, I'm making use of the AWS environment for the demo, but this could also apply to many customers' on-prem environments. So for example, I mentioned the use of using our hardware or Viprion series platforms. We do have customers that are making use of this methodology with their existing on-prem and then adapting it when they move into an AWS, Azure, or GCP type of environment as well. So now that we've kind of laid the stage of what I'm going to be demoing, let's talk about the demo itself. So the demo itself is pretty straightforward. I have to admit that I actually am running this demo off of the HashiCorp GitHub. So I'll kind of show you where the link is, and you'll be able to kind of follow along from home if you'd like to, or take this up later. So within the demo environment, it's pretty straightforward. We've got a couple of different devices that are in it. So if you're following along, I've already kind of, what I'll be doing in a demo is I'll be starting this process, but I've also kind of already built it out, just kind of given the time that we have. But what we're going to start with within this environment is we're going to start with kind of a blank slate. So we're deploying into an AWS environment, and there's no VPCs, there's no subnets, the infrastructure is completely blank. Terraform is going to be used to kind of lay out all of those infrastructure pieces, lay out the VPCs, lay out all of the appropriate security groups, and we're going to launch some devices into the environment. So the devices that we're going to deploy are going to be a BIGIP device. So it's going to be a single BIGIP device. we're also going to deploy Consul. So where we're going to see Consul is in two places within this environment. So Consul can act as a server, which is going to be kind of aggregating information. As part of the demo, we'll actually take a look at the Consul server to kind of look at the information that's being provided. And we'll also be deploying a Consul agent that is going to be attached to a set of Nginx nodes that will have the Consul agent installed on it. So these Nginx nodes are being deployed in an autoscale group. So when we start, we'll have a single Nginx web server as a backend application. And what you'll see in the demo is I'm going to add additional Nginx nodes. And as we add these additional Nginx nodes, we'll take that information over to the Consul server that will then, we'll see these changes reflected on the BIGIP. So with that, let's change screens and go over to the demo. All right. So in the demo, what I'm going to be doing is, if you would like to follow along, this is, again, is on the HashiCorp GitHub. So the URL up here is probably a little bit hard to read, but I'll make sure that we kind of post this afterward. But this is actually from a webinar that was given last year, but I've made some changes so that this can actually be part of F5's virtual agility conference that I'll be talking about after this demo. So if you enjoy this demo during this webinar, you'll also have an opportunity to do this demo hands-on in our June conference. So again, kind of stick around to the end of the demo to kind of hear some more details about how you can join F5 with part of that. So as part of this repository, as I mentioned, I've made this as part of a lab. And within this lab environment, there is a lab guide that's deployed that kind of walks you through how you can deploy this within your own environment. Oh, am I not sharing? Apologies, it seems like my shared window closed. Thank you for the heads up there. All right, so you're probably wondering why I was talking about a blank screen. So this is what I was talking about before. All right, so this is what I was showing before, is that we're talking about the HashiCorp GitHub repo, and this is the lab guide that is part of the that GitHub repo. So if you want to take a look at the docs, they're all kind of here, and you can kind of make merge requests if you want to make any changes into it. So what I'm going to do is I'm just going to be following along with what the lab guide is, and this I'm going to do this cooking show style, where I'm going to start the deployment of the process, and then we'll kind of come back and look at the finished result. So the first step is, as I mentioned, that within our AWS environment, we have kind of a blank slate. So because this is a cooking show, we'll see that I already have a couple of nodes that are up here from kind of the finished product. But the real takeaway that I want you to observe is that we're going to see some additional nodes on this screen. Similarly, from a networking perspective, if you are coming from more of a network background, what you would be aware of is that we're also deploying the entire networking environment as well into this environment right now. Okay, so let's start with the first step of this. So if I kind of just go back to my lab guide, the first part is, and I'm just going to copy and paste the text right here, is we're going to go into this directory right here. And what we have in here is a set of Terraform files that are going to be used for the deployment. I've kind of configured some variables for my specific AWS account, so it's kind of all documented. The important part is that I don't want to make this too much of a demo about Terraform, but really what this command is that I'm applying right now is going to start the process of standing up our demo environment. So we're starting from a situation where there were no resources within the environment. And now, as this is going to be running in the background, it's going to be building this out. So what it's doing right now in the background is it's actually creating that AWS VPC, it's deploying the BIGIP, and it's setting up all the Consul servers in that Nginx environment. So again, I said that this would be cooking show style. Let's take a look at what would happen after we kind of go through the additional steps. So as you're going through this, the next part would be is that we would get to a screen where we would need to kind of deploy the automation tools that are required from this. So this is the case where when we are integrating the BIGIP, I mentioned earlier that the BIGIP is going to be a client for Consul. So what we're going to be doing is we're going to get into a state where the BIGIP is going to be discovering where the infrastructure components is instead of the application owner having to file a ticket to make that change. So this part of it is where we're deploying what we refer to as the Application Services 3 extension, which has an integration with Consul to talk to the Consul API to discover where the different backend components are. So for the Consul itself, I mentioned that the Consul server has been deployed into this environment. And what you can observe here is that we already have that Nginx node that I talked about earlier that has been deployed into this environment. So this Nginx node is currently answering requests. And if I take a look at it right here, we can kind of see that there's currently a single server that is in the environment. Similarly, after you've kind of done that second stage, through the use of the Terraform scripts, we've configured it to use service discovery. So from the BIGIP UI, where that configuration has been applied is within this particular directory. And if we kind of drill down to take a look at where the backend resources are, this is what we refer to as a pool. If you're coming from an Nginx perspective, this would be what you would commonly call an upstream. But this is the kind of workload or service that you are trying to make available to your end users. And right here, we can see that there's kind of a single IP address in here. So what we're going to do next is we're going to modify the number of Nginx instances that are in there. And that's going to kind of finish out the demo of this. So within here, you can see already that my build that I was starting in the background has already kind of completed the additional one. This is the one that I will be modifying as part of the demo. So we'll just kind of crank this up to 3. And then this is also a good segue to say, like, while I'm building this out, if there are any questions that you have about this, I've already seen some people kind of hitting up some questions via chat, but if you could please put them into the Q&A panel. I do have some other folks from F5 that have joined me trying to answer the questions via chat, but we can also answer them live as well. And for folks who are watching on YouTube live, please enter your questions into the chat, and we'll make sure that we get those questions over into this Zoom session as well. So what I want to kind of show right here is that if I go back into my AWS window, we're going to see some additional instances that are going to be appearing. So some of these are coming from my first build that I had done with when I was adding it. But the important part that I want to show is that there are 2 additional nodes that are coming up. So there's 2 additional Nginx nodes that have been added by making that change to auto scale group. If we move over to the Consul UI, what's going to happen over time is if you can kind of imagine in the background, is that right now we have an Nginx server that's being stood up in AWS. And as part of that, there is a Consul agent that's being installed on there. Now, and if we're just talking about a traditional, network load balancer or ELB, it won't, if you install health check, it's going to wait until the traffic's available. The advantage of using Consul agent is that you can add additional logic in there. So maybe it's not just about having Nginx running. Maybe you need to make sure that you have a backend Redis database or some other additional type of checks that you want to do. Using a Consul agent provides you a much more intelligent way to keep track of the state of the device and make sure that you're only adding it in when that service is available. So that's kind of a key part of it, is that it's not only just kind of showing where the additional node is, but it's also tracking the health of it that you've configured or specified through configuration. So just with a refresh of the page, we can see that we have those additional Nginx resources that are in here, and we can observe that the Consul agent has propagated the identity of these Nginx web servers to Consul. So this is important information because if we go back to my earlier point, at this point, this is where you would normally have to go to your network team to say, I've added, this IP address and this IP address. Please make a change during your next change window. But we don't have to do this because we're using our integration between BIGIP and Consul. And a way that we can see that is if we go back to the BIGIP and I refresh this window here, is that the BIGIP has been talking constantly to Consul. So you can kind of imagine in the background, there's this loop where the BIGIP is talking to Consul to just check, are there additional nodes that are available? So the same way that I was refreshing that web page before, that's what the BIGIP was doing. And if we go back to the screen here, this is kind of the original Nginx web server. If I kind of refresh this page, what we'll see here is that we can now see that as an end user is going into the environment, they are being dynamically distributed across those new additional nodes. So that kind of concludes the kind of demo part of this. Let's go take a look at Q&A and see if we've got anything that we want to answer live.
Thanks, Eric. So we did have a couple of questions come in. So you mentioned briefly where this lab was available. Can you walk through just again, like how to get access to the lab demo and then also where the guide is?
Sure. And I need to share again. So I mentioned earlier that if you do want to do this lab immediately following this webinar, we do have this up on GitHub. So right here, hopefully you can see this clear on your screen, but that is the URL where you can kind of git clone it. So this is just, for folks who are following along with the demo, this slide just kind of shows you the different ones. But, if you want to run this from home, this is actually, I created a QR code for this. So, I'm just imagining everyone right now holding up their phone, right? Okay. Yeah, I'm in the photo too. Hi. Okay. So take a picture of it. There's also a YouTube video that's linked off that page. It's not me on that particular page, unfortunately, but if you want to see a demo of it, there's also that recording as well. So that's a way that you can kind of do this on your own. I also mentioned that, maybe you actually want to get this demo delivered to you. I've been doing a lot more, I do takeout, but I've also been doing a lot more deliveries lately. So we're actually going to be delivering this demo to you. So you don't even need to leave your house. That's going to be happening in June. We haven't set up the registration for this process yet, but you may want to just kind of block out your calendar. If you're like many people, your calendar you probably wonder, why am I in so many meetings now? So, maybe just take the time, go into calendar, block out those 2 dates, and then you can come back and join us. And the same environment that I was just showing you earlier, where I was running this demo, you would be able to do yourself hands-on. So it's a great opportunity for folks who want to try this themselves, kick the tires, play around with some more of the AWS environment, can get more hands-on experience of using the BIGIP and Consul integration.
Awesome. So we have one question come in here about using BIGIP, obviously, for load balancers to their cloud, but they're also using the Kubernetes ingresses for their Kubernetes clusters. Is there a way that you could combine using BIGIP and the Kubernetes ingresses with Consul to improve their experience?
So there are many ways that you can kind of do automation with the BIGIP. What I was demoing today is part of what we refer to as automation toolchain, which is making use of the application services extension. The question was also asking about a solution that we call the container ingress services that is kind of more geared for our Kubernetes integration. In both examples, you can kind of think of it as the problem statement that you're trying to solve is you have resources, services that are being stood up, and you need a way to be able to kind of dynamically discover it. To me, the answer is going to depend on the customer environment. So for some of our customers that are deploying in Kubernetes, and they may not have a need for additional Consul services, then the container ingress service is going to check that box very well. But I had mentioned some of the sophistication of what you could do with Consul that you may not get out of kind of the native Kubernetes services. So that's a case where, you could kind of consider, do I want to maybe take a hybrid approach, right? Where I've seen customers who want to take more of an approach of maybe instead of having the infrastructure being the trigger for all this, maybe you're making use of your CI/CD pipeline and service discovery natively from the BIGIP and not making use of things like the built-in Kubernetes ingress types. So, a lot of that's going to depend on the type of workload and what you're trying to achieve from that.
Awesome. So we had a couple questions that we did provide the links for, but I think it would be good to go through. Can you walk a little bit through how Consul and BIGIP integrate and what AS3 really is? I think some background on that might be helpful for folks.
Sure. So with the integration itself, the BIGIP is, so let's just go back to one of my previous slides right here. I'll just kind of go back and share again, just to kind of finish this out and talk about how the solution was working and what we were seeing on the screen, because now that we've kind of seen the demo, hopefully some of this is going to make more sense. So traditionally, what's actually diagrammed on the screen is a case of using DNS to make use of service discovery. This is kind of a common way that customers will use Consul, is that you would just look up an FQDN and it would return it. What we were actually showing in a demo was that we were actually making use of the Consul API. So if you can imagine, the BIGIP is acting as the client, and it was querying the Consul service to discover where those new additional Nginx resources were. Once it saw that there were additional resources that were available, it made use of what I was referring to earlier, the application services extension, to make the update on the BIGIP. So that was kind of all happening in the background.
Excellent, thank you. And also one of the things I want to mention to everyone is that we do have a Learn Guide for walking through how to be able to use F5 BIGIP and Consul. And I've gone ahead and posted that into the chat if folks would like to have that. So Eric is actually going to be available towards the end for our Q&A panel. So please continue to enter questions and just make sure that you direct them at F5 for us. So that way we know to make sure to ask him. I want to appreciate him for his time in the demo today, but we're going to move on to the next section. So thank you so much, Eric. Appreciate it. Next up, we're going to cover a little bit about Service Mesh. So Jono Sosuska, who is our digital developer advocate, is going to walk through an introduction about how you can use Consul for Service Mesh. So Jono, I'll turn it over to you.
All right, thank you very much, Peter. Thank you everyone for joining us for this Consul Virtual Adoption Day. The topic that I'm going to be going through is getting started with Service Mesh. And without further ado, let's go ahead and dive into it. I have to say, I'm very lucky Sriram helped prime a little bit of this for us ahead of time. So some of the design patterns he acknowledged in the architecture, you'll be able to look at moving forward. A bit about me, I am currently a digital developer advocate with HashiCorp, focused predominantly on the Consul product, and it has been one of my favorite experiences with the entire community. I've been able to be an on-call SRE, a dojo coach, and work in the cloud migration spaces. So I really appreciate the operational type of experiences that I've gained throughout the years. And diving into Service Mesh does require a little bit of background. Hopefully this track's going to help color that. Feel free to reach out to me. I have my contact information at the end of all of this, and we'll go from there. So I'm going to start with a story. Like a lot of people, I've been stuck in my home for the past couple of weeks, and I think that may affect why I'm having this particular illustration. But let's start with my story of living in an apartment building. One day, I get an email that there's a new resident, and I look at the name in my directory. I see that it's my friend Sam, and I'm really excited. I want to go and see them right away. So I give them a call, and I say, hey, let's set up a time to go visit. And then when I go there, we spend a lot of time catching up, figuring out what we need, and then going from there. I also invite him over anytime he wants. Now, why am I talking about an apartment complex when we're talking about Service Mesh? In a lot of ways, Service Mesh is like an apartment complex. When we're talking about the technique of a Service Mesh, it's mostly a design pattern for connecting and securing services. In our analogy, the apartment complex itself is this mesh. It allows all of the apartments to be connected together and everyone to go through the complex as they need it. When we're talking about services, we're talking about discrete applications, configurations, and their component operating systems, all contributing to the infrastructure that is meshed together. In this particular instance, we're going to be using containers, but these design patterns also apply to your virtual machines and your bare metal machines, like we've seen discussed so far. We're also going to touch on service discovery a bit more as what Eric was able to do. And this is where we're talking about finding a service when it's needed, not where we expect it to be. Last but not least, we'll be talking about sidecar proxies. This is one of those major components that ends up transitioning what is a service mesh into how to use a service mesh. These are the doors for our communication and provide also the security between all of this. So I do have a demo that I'm going to dive into here, but let's talk about what we're going to go through. First, we're going to build the actual apartment complex, the mesh itself. We're going to move some services into the apartment, going to see them talk to each other and make sure that they're able to be secured. And last but not least, go through and meet the neighbors, see what are some things that we can do with this service mesh design pattern. All right, let's go ahead and dive right in. So on my screen, you'll see a couple different screens. In this panel, I'm using K9s, which is a wonderful visualization tool from the CLI that allows us to see what's currently running on my Kubernetes cluster. Here I'm using Minikube in the background, and it's providing my core services. Up here, I'm going to be using this particular space for all of my commands, so that way we can find where we need to go and what we need to do to get this set up and configured. In this folder, I also have a couple values files that I'll be going over, but let's go ahead and jump ahead. All of the links that I'm using and all of the commands as well too are provided in some of the additional references that I have. Just to show what we're doing here, I cloned a repository in at a specific branch, so I have a specific version of our Consul Helm chart. This Helm chart is going to help me configure Consul within Kubernetes to function as our service mesh. Went through and named it to something a little bit more explicit, so that way I can find it. And then I'm going to just remove the Git folder there, so that way it's a clean workspace. Now let's take a look at one of those files. This here is our values file. It looks just like any other file for those who are familiar with Helm. This values file maps to a values file that we also provide in the Consul Helm chart. It is a very well-detailed values file that gives you a lot of different options and use cases, but we also document it on our website for those who want to go through and research it. Again, those links will be provided at the end. The first section is our global section, and there we're giving just the configuration information that we need for deploying our Consul data center. We're specifying the version. We're also going to be deploying with the servers. In this particular instance, this example is suitable for development mode, not production, where I'm spinning up a single node and a single set of pods for the servers. The client section is also going to be so that way we can launch some of the clients within our cluster, kind of within line of the architecture that we've seen so far. And then we're going to turn on the UI for Consul. And last but not least, use this connect inject stanza. And I'll talk about that a little bit more later, why that's important, but just remember that's there. All right, so let's go ahead and get our service mesh set up and good to go. So what this is doing is I'm using Helm. For those who don't know, you can search Helm on Google, Helm Kubernetes, and this tool gives you a consistently repeatable way to deploy your services. I'm using that file for those service definitions, and we're watching everything come up on this side here. While we're waiting for the client here to come up to health, we're going to also check to see if we can get to the UI. So again, I'm using Minikube as a tool. It has this wonderful service list, which shows me my URL and where it's available. Let's go ahead and pull that up. All right, so here we have my Consul UI brought up within a couple minutes. I can see the node for my clients as well as my server nodes, and I'm able to access everything like I would as if it was a bare metal system. Cool, so that all works. Let's just review real briefly here. We've set up our service mesh. We've built an apartment complex a lot faster than I've ever seen an apartment complex go up. Now we actually need to move some people into the apartment complex, build some services within our service mesh. So let's go ahead and dive right in. These files will also be provided in a GitHub URL when all of the rest of the information gets released, but I'm just going to review them real quickly here. This is a Kubernetes deployment, so that means we're going to be using kubectl to do a deployment of this service. And that's our API. We're also going to go ahead and take a look at our web service here. What we did here is we defined a deployment. We also defined this really cool section up here called annotations, which I'll get into in a little bit regarding that connect inject stanza. And then we also exposed a service to the world so that way we can go through and reach it. All right, so let's go ahead and fire that off. Sorry, that got too much. All right, that launched, and let's go ahead and run our web. Cool. So as these services are coming up, what I want to do is check to see where that URL is. I want to make sure that my services, when they come up, are actually working the way I expect them. And there's a handy dandy link there. And we'll use, yeah. So we see that the API for that is accessible, and here's our UI. So this is a really handy dandy service that we like to use. It goes through and really clearly shows me, hey, I'm able to go through and talk between these services and that they're set up and good to go. So going back to our apartment illustration, we've now moved some services in. How do we actually give them those permissions for going through and talking to each other? It must be pretty complex, right? Well, maybe it isn't. Here I'm using a for loop to go through and just take a look at these files. This section here with annotations provides the needed information for the connect inject sidecar to deploy these proxy servers or services. As I mentioned earlier, sidecar proxies are how the mesh provides communication back and forth. And in this particular instance, we have a default allow that says, hey, we're able to talk to anyone who has these annotations within my namespace. So just like you can't move into an apartment without having a door, we have a door provided for us as soon as the services launch, and that door is able to be quickly configured by developers. So let's go ahead and meet the neighbors. Now, one of the things that I want to go through and do is verify we've done a deployment with these servers, our services. We've gone through and launched them in Kubernetes. We can see them there, but can Consul? So I'm going to use some port forwarding here to go through and get us set up. Now, I'm also going to connect to the Consul agent on the client, so that way we can see the connectivity between all of the hosts as well, too. And I'm going to throw this into the background. Awesome. So I have a local binary of Consul in my path. I'm going to do Consul members. And I can see the nodes that we saw reflected in the UI, as well as what's reflected through my K9s tool. And then what I'm going to do is take a look at the services, because we haven't done any registration of services, at least any differently than what you would normally do when deploying. We can see that we have Consul, our web services, and those proxies there. So what can we do with those proxies? One of the things that was mentioned earlier, or at least in the chat, was this concept of intentions. Much like when I intend to go and visit my neighbor, I'm going to go through and state that intention to them. I don't know about you. I personally don't like dropping in unannounced. So I want to check that. Can our web talk to our API? Yeah, it can. Cool. Now let's go the other way. Let's make sure that we have both directions. All right. This is a good scenario because we have, all right, we want our services to talk to each other, but let's say something malicious happens, something that makes us a little concerned about which services are talking to each other, regardless of where they're deployed. Here, I'm going to create an intention to block the web service from talking to the API service. And if we take a look on this side, we see it reflecting that it's lost connectivity and there's an issue. So let's go through and just review what we've talked about so far. We built the apartment complex. We went through and had Kubernetes deployed, launched a Helm chart with Consul, and made sure that it was configured to correctly inject sidecar proxies. We deployed 2 services, much like moving in 2 people into the apartment complex, and made sure that they were running and healthy. We configured the proxies straight out of the box, and then we played around a little bit with intentions. And understanding intentions is a core part of how Consul is able to easily manage these traffic patterns. So now, just a quick review. Why use Consul as a service mesh? I'm obviously biased. I love the product. I use it. I'm an advocate for it. But that's not enough because, unfortunately, I can't be with you on all of your deployments. However, what we do provide is Kubernetes as a first-class integration point. So you get a lot of those automated features that you expect out of an orchestrator, like your sidecar injection and your registry sync. What we've also been developing and working on in our newer releases, something to look forward to, is secure federation of multiple Kubernetes clusters. We'll talk about this more in depth in the future. Feel free to drop any questions about that in the chat. We're also platform agnostic. So this service mesh pattern can apply to servers, VMs, containers, or mixes of these environments. And we're also rolling out new ways to connect these services together with ingress and terminating gateways, which you'll want to watch for releases for. Last but not least, Consul integrates with a huge fleet of HashiCorp products. We have a Terraform provider to help ease the infrastructure automation of getting your Consul cluster set up. We have Vault as a trusted security authority, a certificate authority and security layer. And then we can also integrate with Nomad for use as a scheduler for our service mesh. So I hope you've enjoyed this getting started. What I've provided here is a QR code. I'm going to leave this up for a couple minutes here, so that way people can feel free to screenshot and get any additional information that they may need. I also encourage you all to reach out and contact me. I'm available on our Discuss forums, discuss.hashicorp.com, Twitter, and email as well too. And the information that I've provided will be released with all of the recordings as well too. That QR code will take you to a link in our GitHub gist where we provide access to resources like a Learn guide that is recently released that walks through the same process that I did here using a slightly different Kubernetes provider locally. Information on how to demystify service mesh, getting access to it, what are the things that make it work, and other design guides for how to run Kubernetes or how to run Consul on Kubernetes. So with that, I want to thank you all for taking the time to be here today, and I'll pass it back to you, Peter.
Thanks, Jono. And so just as a reminder, please go ahead and enter your questions into the chat. We're going to go ahead and do a live panelist Q&A with our HashiCorp speakers. So now that we've covered a little bit about an introduction to Service Mesh, we're going to have Nicole Hubbard, a developer advocate here at HashiCorp, talk a little bit about how you can see what's going on inside that Service Mesh. So I'm going to turn it over to Nicole to talk about observability.
All right. Hi, everyone. So my talk will go directly after Jono's. And so everything you've learned there, we're going to use and extend upon. So one of the things that's big right now is observability. So what is observability? Well, it's a really hot word and everyone wants to know more and they're trying to add it. But really it comes from control theory, actually, which is it describes the ability to measure the internal state of a system from the knowledge and information you can gather outside of the system. So metrics, and so all of these things, metrics, health checks, tracing, access logs. If you've got specific application metrics or application logs. And so one of the things we're going to talk about today is specifically with tracing and layer 7. And so when we're dealing with failures, we have a lot of different kinds of failures that we can see. There's full systems failure, everything's down, nothing's responding. These are easy to find out. Your monitoring catches these and you will, or your customers will notify you. These don't go missed, but then some of them get harder. What if a single node has failed or is intermittently failing? Or you just have a single instance of your app services running that's failing. And so in order to figure out where your failures are happening when they're smaller, more intermittent, it's useful to be able to pinpoint the data that's causing those failures and see information about those calls. And so we'll show how you can do that with a couple different things here today. And then just to go into a little detail on layer 7, there's connections and requests. With the Envoy proxy that's running, your connection gets opened between the proxies and then that connection is left open. It's not reestablished every single time for every call. And then the different requests will flow over that existing connection. So that helps speed up things and reduce the ability or reduce the requirement to re-authenticate and ensure that that intention is there to allow those services to talk. And then failed requests don't always cause a disconnect. So that proxy could leave requests that connection open. Sometimes a failure could be the service died and that connection gets terminated. And then it's also really helpful to be able to see the status codes as well as gRPC methods names. And so we'll show how all of that data is available in the trace. And so what does this look like? So similar to what Jono deployed, we've got service A and service B running. They're each in their own pods inside of Kubernetes, and they've got that sidecar proxy deployed. And that was automatically injected by Consul for you, and Consul's running there in the cluster. Then also in your cluster, you can run, for example, a Datadog agent. And so your applications will emit metrics and traces to the Datadog agent. The sidecar proxies will emit metrics and traces to the Datadog agent. And then that agent will forward those over to Datadog so you can see them in their dashboard. You can also use tools like Zipkin and Jaeger, which I will also show today in addition to the Datadog demo. And then one thing that's really important to keep in mind, the service mesh is not a silver bullet. This will add some observability and give you a lot of insights into the network calls and traces that are happening in your network. You can do authentication, you get zero trust networking. You get a lot of things with service mesh, but it's not going to solve every problem you have. And it's not going to be able to do some things you might want to do. And with that, let's dig into the demo because demos are more fun than slides. So let's go ahead and jump over here. And so what we have is we've just checked out a Consul demo tracing repo that we actually have up on the HashiCorp GitHub. And so what is in here is we have a Consul config. There we go. And so if we look here, we can actually see that this is a full config file for a Consul server. It'll be passed into the container running Consul. So we're setting our data center, we're setting ports that we want to listen to for gRPC, we're enabling connect, similar to everything Jono did before. But we now added telemetry for dogstat-d and we give it an endpoint. And then farther down, we also configure an Envoy dogstats-d URL so that our Envoy sidecar proxies are sending their data. And then we add a static cluster config that defines an endpoint for Datadog and where we can hit that here. And we define the name. And then inside, we now set up some Envoy tracing JSON, which is for HTTP, use Envoy tracers Datadog, and send it to that service we defined with the service name Envoy. And so that's all there is to that. And now if we look, we can actually check out the central config that we're going to use within Consul. And we can look at our ingress. So by default, we're just defining our ingress with some defaults that the protocol is HTTP. And then we have our web defaults, which is defining it with the name web, and the protocol is also HTTP. But then we have our API service, and this one actually has a protocol of gRPC. So this will, since we're making sure Consul knows the different types of protocols that are being used for the connect, it can ensure it sets up the tracing correctly. So we'll get tracing for both our gRPC and HTTP requests. And now we can check out the service configs specifically for these. So for ingress, we're defining that this is our V1 ingress. It's listening on port 9090 on this IP. We're going to go ahead and set up a sidecar proxy that's listening on 2000 or 20,000. And one of the things we want to be able to talk to is the web service that we defined. And we want to be able to talk to it on 9091 locally for us. And then we kind of do the same thing with both web. So web does the same basic setup, port 9090, but we want to be able to talk to the API service on port 9091 locally. And then our API service. So this one does not actually have any proxies because the API service isn't talking to any other services. So we're just defining the API service here. And so this is in the case where you're doing this without Kubernetes with the automatic connect injection and the annotations to make that work for you. So now this one's got a Docker Compose YAML. So what we have here, we've got our console image starting up first. So we're running console and we are passing it that console config that I showed. And then we're running a fake service, and this is our ingress service. So it's going to have an upstream URI of that localhost 9091, which actually goes back to the Envoy proxy, and we'll forward it. And then we set up some timings for 50th, 90th, and 99th percentile so we can measure that. And then we also add tracing and metrics for Datadog to our application. And this is because we've added the tracing and metrics into our application so that it can emit those metrics for us. And then if we continue down, we see more of the same. Here's our actual ingress Envoy proxy. And so we can see we're passing it config in. And then we've got our web service, and it's very much the same thing, other than its upstream URI is actually gRPC to localhost 9091. And this will hit the proxy and forward that request to the API. And then our web proxy Envoy instance is running here. And then last, we have our API service. And one thing to note here, the server type's gRPC now. We're still emitting these tracing and metrics data, but we've also added an error rate of 0.2. So about 20% of requests that hit the API server are going to fail. And so this will allow us to be able to see tracing details when there's an error. And then we've got our API proxy Envoy sidecar running there, just configured the exact same way as the others. And then we're also running a Datadog agent. And so this is running to collect that data and actually ship it over to Datadog so we can see it in their dashboards. And then we define a custom network for us so that we have a network to work within so that we can have all these static IPs without any overlap. So now let's go ahead and bring this all up with Docker Compose up. And so this is starting all of our containers. And now we can see they're all started and we're getting our logs from them. And so we see all the logs from everything as they start and come up. So if we jump over here to the browser, we can go localhost 8500. Oh, where's my console? Console's still starting, it looks like. All right, so the containers are still coming up, so they're not fully responding yet, it looks like. Uh-oh. It's always best doing live demos. Let's see real quick here. Make sure I don't have the wrong port real quick. Docker Compose and scroll up to console. Yeah, 8500. Okay. Oh, I know why it's not working. I have to tell it I want the UI. Maybe. Oh, come on. Okay, well, let's see if we can access our application or if something broke entirely. Yeah. All right, so we've got our application running at least, and we can access that, and they're able to communicate. So Consul is up. Just not sure why this doesn't want to load for me. Something's going on with the Consul UI there, but it is running. So I'll have to dig into that and figure out why that didn't work. But we can see we've got our ingress service, which is what we hit for this request. We've got our web service, which was gone to from there, and then our API service. And if we refresh a couple times, we'll see eventually this fails because about 20% of requests will fail. And so now we can actually start digging into all of this data that we're shipping to Datadog. So if we jump over here to Datadog, we've got our dashboard, and it's going to show. So we can actually come over here and look at APM and look at our services. And we'll be able to see that our services are now responding. And we've got our ingress service, our API service, and our web service. And then we've also got an Envoy service that represents all of our Envoy proxies. And we can see for each of these services what our error rates are, and we can actually drill into them and see more information as requests continue to flow. I think I can knock this 15 minutes, see a little more data. But as those continue to run, we'll be able to see even more data come through. And then we can also see a service map. And so this will show us all of our services and how they communicate. Since everything goes through the Envoy proxy, it is by far our largest service. And ingress talks to Envoy, which then talks to the web service through there. And then the web service talks through Envoy to get to the API service. And so it's able to build that all out just based on all the tracing data we have. So now if we actually dig in, we can look at some of these traces. And so now we can see all of these different traces we have. And if we dig into, let's start with one that was successful. We're able to see that the request came in and it hit handle request, which is the process inside of our application, inside of ingress. And then it made a call to call upstream, which talked to an egress Envoy proxy on localhost 9091, which then went to another Envoy proxy for ingress. And so from there, we can actually see on this one, we get all of the HTTP data. So we can see what the response size was when it was returned and any other information we want, as well as the cluster and HTTP parameters that were passed around. And then from there, our web application handled the request and it followed that same process of call upstream, which then made a call to our egress. So we can see the egress received a post on with gRPC here, and that our user agent was actually gRPC Go. And then we can see where this was received by the ingress or by the Envoy proxy for our API service. And we can see all of the data here for that. And then we can see where we actually handle that request inside of the API service. And since there wasn't an error, all of these services also happen to have a built-in service delay function. And this just is to slow down the response and show how you can see all the different function calls that are being made. And so then when the request came back after call upstream, we actually called service delay here in the web. And it didn't make any external calls, so there's nothing under it. And then as the request came back all the way up into our ingress, we called service delay there. And these are just random times, so we can see how long things take. And with all this, we're also able to see metrics. So we can see when our trace was right there. We can also see what our CPU utilization looked like, load averages from our system when this ran, what memory looked like at this exact time, disk latency, network. So all of this data that would help you potentially figure out why something failed if this was a failure. So now let's drill into an actual failure. And so now we have one where it failed. And so one of the things you'll notice if we look in our application over here, when this fails, we just return a 500 from the ingress. we're not returning the error directly from the application at the API layer to the end users. So what the end users see is they just get an error processing upstream request at that IP address or that URI. And so that's all that's returned in the error message there. But as we drill down, we can see, okay, so in here where we handled this, we received an error in our web service that said RPC error, because we're using gRPC, and the code is unavailable. The description is service error automatically injected. And we're like, okay, so that gives us some information. Now we can drill all the way into the API and we can see the full stack trace, and we can see errors were generated with an error string and that is service error automatically injected. So we can actually see our entire trace here of what was happening. And in this case, we just hit the random 20% case. And so we threw an error, but we're able to see all of that data as well as, we can see the metrics like I was showing before. But one nice thing is we have an errors tab, and this will show us every error that happened in the entire stack for this call in one screen. So we can actually see all of them in one place if we wanted to be able to drill into those more. And so now that we've shown this, let's jump back over here and let's go ahead and stop this environment. And while this is stopping, the next thing we're going to do is down just to go ahead and remove everything. So now close that one. So now we're going to leverage a tool that we built, some of our team built here, called Shipyard. And so this allows you to run cloud native deployments. So Nomad, Kubernetes, leverage Consul, leverage all of these things easily inside a local dev environment by specifying some HCL, and it'll automatically configure this for you. So let's dig into what this looks like. We can go ahead and close this tab now. And so now the first thing, we're going to define our Kubernetes cluster that we want to run this in. So HCL. And so what we did was we defined a K8s cluster, we call it K3S, and we're using the driver for K3S. This way we get a really fast, lightweight Kubernetes cluster. And then we're going to define a K8s config for what we're going to call app. We're going to use our K3S cluster, and we're going to use Helm console. So we're going to say that that's required before this continues. And then we're going to also pass it this directory, and it will just apply all of these kube configs for us. But since we have wait until ready, it won't apply these until our Helm cluster is online. So let's take our Helm deployment is done. So let's look at our Helm deployment now. And so Helm, what we're doing with Helm is deploying Consul. We're deploying it into that cluster with the chart Consul Helm 0.16.2, and we're giving it the values file. And so this is exactly like what Jono showed just a little bit ago, where we have a values file. And so let's go ahead and dig into what that looks like. Oh, and before that, this is the health check we use, so that up here where we're depending on this, we can actually use this health check, which will be any pods that have release equals console. So those have to go into a ready state before this deployment is considered done. So now Helm console values. And so this is our values YAML file, like what Jono showed, and this will overwrite any values that are defaulted in the default values, but those values will still be used if they're not overrun. So we just enable everything, one replica, one bootstrap. We start our clients, we bring the UI up, we enable a service for it. And so we turn on connect inject, so this is our injection sidecar. We turn on central config because we're going to leverage that. We set our default protocol to TCP. Then we define some proxy defaults. So we're going to tell Envoy proxies to run Prometheus and listen publicly available on 9102. And then we define the same extra static cluster JSON that we defined for the Datadog demo. So we've got JSON in here, so it doesn't look as pretty because it has to be escaped. But this is going to go to a service called Jaeger Collector. And then we've got our Envoy tracing JSON, which tells it for the sidecars, send all of your tracing information to the Jaeger 9411 cluster. and use this endpoint with the name envoy.zipkin. And now we can actually show our ingresses real quick. So here we just define all of our ingresses so that things can be publicly available. And we can actually tell it to open these in the browser for us as they come online. So we just define all the services we're starting. And now the last pieces are the Kubernetes configs. So we've got our application. So this is like what Jono showed. And so we've got our service for our web, and then we've got our front end web. And you can see here, we actually are using the connect inject true, the connect service upstreams or API, but then we also add a connect service protocol of HTTP. That way connect knows that this service talks in HTTP. Then if we scroll down, we're also setting our tracing for Zipkin to use Jaeger collector, which will be the Kubernetes service. And then we've got our API service that we're going to go ahead and define. It'll be very similar to the same thing, specifying service tags, and the connect service protocol is HTTP. And so this runs, and it's also got the tracing Zipkin defined. So now let's go ahead and bring this all up. So shipyard run dot. And so this will start shipyard, and it will start all of these services for us, including creating our Kubernetes cluster, defining the network for it, bringing online the services that we had, as well as opening our browser automatically for us to the pages we asked it to. So this is starting. So as you can see, it's using K3S from Rancher so that it can actually create our cluster. So this is going, it only takes about a minute. So this will. So this part takes a second because we're waiting for all of the Kubernetes components to start, because we're creating our own Kubernetes cluster from scratch here. And so this is really useful for dev environments where you can do this. I see one question about, do we need to talk to the API through gRPC? So in this case, depending on which part, for the Docker Compose file, the API service was listening in gRPC, but here in the shipyard demo, the API service is actually running as an HTTP listener, so we don't define it as gRPC. So here we can see this is doing our Helm deploy for Consul. So we're just waiting for our Consul releases to come up. And so we can see here, here's our Consul service application. And we can see that our API and our web services are now available. Sidecar proxies have started. They're not quite passing health checks yet. It takes them a second. And we see Jaeger's now running. But if we watch, these will start passing health checks momentarily. So we can actually see here, we've got our fake service running and the web service can talk to the API. And if, we can generate a bunch of requests to see that. And then now we can see all of our services are passing health checks for this. And now if we dig into Jaeger, we can actually see over here, we can click a service and we can say, show us our API service and show us all of the results that you have. You can see here's one that just happened a moment ago. So we can dig, before we dig in though, you can actually see there's one request to API, one to API v1, or sorry, two to API v1, and 4 requests to the web service within this. And so what happens is the web gets handled requests, just like we showed in Datadog, and then we call upstream. And then this actually makes the call over to our API services. And unfortunately, it looks like the Envoy sidecar proxies for these services started before Jaeger was started. And so if we actually jump back over here, we can actually fix that. So that's why we're not seeing Envoy in our, we're not seeing Envoy in this request stream because the order that these all started. But, okay. Oh, the Kubernetes clusters aren't. Oh, darn. Okay. But once those restart again, those will start responding and sending their metrics over. But I'm about at time now. So with that, I just want to say thanks. And we will make sure I get these Datadog Kubernetes examples and the Jaeger Kubernetes examples added to the GitHub repo on observability within Consul so that you can actually deploy these and try them out yourself. And with that, I'll hand it back to Peter.
Thanks, Nicole. A lot of great information. So we just went through 2 consecutive sessions talking about service mesh. I do want to make a call out that we do have a getting started with service mesh track on our Learn Guides. I've dropped that link into the attendee chat, and then I'm also dropping it into our YouTube live. So if you want to get started with some of these examples, this is a great opportunity to. If you think of any other questions on the observability piece, Nicole will be joining us at the end for our live panel to answer any questions. At this point, we're going to shift gears now a little bit. I'm going to introduce Cody DeArkland. He's our technical product marketing manager on Consul, and he's going to be talking about HashiCorp Consul services on Azure, which we announced at HashiCorp last year, and how it worked with Azure Kubernetes Service. So Cody, I'll go ahead and turn it over to you.
All right, thanks a ton, Peter. So hello, everyone. My name is Cody DeArkland, and I'm going to talk to you about, as Peter mentioned, HashiCorp Consul service on Azure. A few quick things about me.
Cody, you may just need to restart your mic. We're getting a little bit of feedback. It's coming through a little grainy.
Let me check real quick. Give me 1 sec. We'll fix this. Give me 1 second here. All right, Peter, is that any better?
Much better.
Fantastic. Sorry about that, everyone. Little last day jitters there. So again, my name is Cody DeArkland. I'm technical marketing representing Consul. You can see a little bit of facts about me. I'm not going to dive into everything on this slide. It's really easy to get a hold of me on Twitter. If you have questions about anything that I talk about during this presentation, I'm happy to answer them. Feel free to ping me. You can see some of my rambling on the HashiCorp blog as well as my personal blog. But the most important thing that I want to call out is that I focus more on doing demos and trying to keep slideware at a minimum. We've got a couple of slides that we got to get through around what HashiCorp Consul service on Azure is and kind of the problems it solves. But then we're going to get pretty quickly into some demos and show some really interesting ways that we can use HCS. So let's talk a little bit about where we're going to end up, or where we're going to go through in this demo. We're going to talk a little bit about what HashiCorp Consul service on Azure is, like at its core as far as the product goes. We're going to talk a little bit about how we get it deployed through the Azure Marketplace. From there, we're going to go ahead and bring an Azure Kubernetes cluster into that HCS cluster. We are then going to talk about how we deploy applications and have them available inside of the platform. And then finally, we're going to jump into a little bit of a secret part of the demo that we're going to hope doesn't break. One of the things I want to call out, and Peter hit on this right before he transitioned over to me, all the stuff I'm covering here is available in our Learn Guides, maybe not specifically for HashiCorp Consul service yet, but one of the big benefits of Consul is being a consistent networking platform. And part of that big aspect of being consistent is that the same functionality exists between any platform that you deploy Consul on. So you can see these Learn Guides, go through and learn how to actually configure the stuff I'm going to show you in here. This is where we're going to end up. Apologies for the little bit of blurriness on the image there. We're going to end up with our HashiCorp Consul service. We're going to end up with a AKS cluster deployed, an Azure virtual machine, virtual net also, and we're going to pair all these together, and we're going to have some applications talking between them. First up, though, what is HCS, HashiCorp Consul service? This is a managed Consul offering. What that means is that we take care of the underlying infrastructure. Instead of you having to deploy, scale, make sure everything's running, we take care of all of that and make sure that the cluster itself is up and running and the platform itself is taken care of. So you can get back to actually operating, doing the service mesh, service discovery, all of these things that you normally do with Consul. You can focus on the actual operations of it instead of focusing on how to deploy it and how to maintain it. As far as Consul goes overall, it's a multi-platform tool. We really stress that this is something that you should be able to bring in existing infrastructure into, as well as that next generation stuff inside of Kubernetes. We're really about the journey. Sounds kind of funny to say it that way, but we care a lot about our operators being able to work with infrastructure they already have and workflows that they've already established. You shouldn't have to adopt a service mesh and move all of your workloads into Kubernetes to be successful, right? You should be able to bring existing workloads into that and get some of those benefits, even if you aren't doing the service mesh, even if you're doing things like Eric talked about earlier around load balancing with F5 as an example. One of the cool things about HCS, because it's a managed platform, we've set it up to be secured by default, which means that encryption's turned on. We're setting this up to be a really secure platform. And again, beyond that, we bring in more than just the service mesh aspects with things like discovery and health, and making sure that you can actually take advantage of things that don't necessarily require like a microservices approach. So that was it. That was the slide where we're going to jump into demo time. So I'm going to switch over into the Azure console. I want to touch first on how you actually get a HCS cluster in your hands. First off, we're running a private beta. You can sign up for it. And once your account is whitelisted, you can come into the Azure Marketplace and just type in Consul, and you'll see the HashiCorp Consul service on Azure preview show up. We can go in, we can do create, and we can start to fill out our different details from our resource groups. So I have my existing resource group in here. I'll give it a simple name, Consul Adoption Day. And after we fill in this information, we can actually have a Consul cluster in hand and ready to actually function. So it takes a little while to provision. So fortunately, I already have one provision that we can work with. So we can see this here. This Consul cluster is taking over from a couple of previous demos that I've done and recorded on HCS. So it's fairly set up, and it's got a couple of things in it already. It doesn't have the AKS clusters in play because we're going to show setting that up live. But what it does have is several VMs already in place. We've got services actually registered. So if we hit our nodes, we can see I have a ton of VMs deployed from inside of my Azure environment, and those are reflected in my resource group here. So if we dive into Azure, we can see all those nodes exist in both environments. And then from an actual services perspective, we got the applications actually registered. If we go into our front end application, we can see that is running on a virtual machine. And what we have configured here is an actual service mesh between these virtual machine objects. Now, that's not the point of this demo. The point of this demo is to dive into bringing AKS into the fold. But I wanted to touch on, this is not unlike most customer environments. We've already got virtual machines in place. We're looking to move to Kubernetes and bring Kubernetes in as more of like a first-class citizen inside of our infrastructure, inside of our deployments. In this case, I've got my mesh established. I've got VMs talking. I've got the application up and running over here. Very simple application that I threw together for showing demos like this. We can see that it's a 3-tier application. It's got a front end, an API, and a database. If I hit this tab, we can see I'm on the VM-based database. Right. So now we're going to go ahead and look at how we can start to get this fired off with HCS. Fortunately, Jono and Nicole did a great job of going through and talking about how we use things like Consul Helm to deploy out Consul onto infrastructure in Kubernetes. I'm going to touch on a couple of slight differences. In this case, because Consul is already operating as a server cluster, we just need to join our AKS cluster as agents. So if I do a kube control, get nodes, we can see my existing AKS cluster in play. Now, this one is set up right now to use what what Azure or Microsoft calls the Azure CNI. So what that means is that every pod that deploys inside of Kubernetes gets its own IP address from the actual subnet that it's been assigned to, which means we have routability directly in as long as we peer the VNets. And you would have seen that in the diagram I showed earlier where I highlighted showing the different VNet peerings that exist between those environments. So in this case, the AKS cluster is already deployed and peered up to the HCS VNet, which means that we have communication between. If we take a look in this directory, there's a couple of things in here. I have a script in here that's generate Helm config. This was written by one of our really great engineers who focuses a lot on the Kubernetes platform, Irina Shistova. She's actually on here for Q&A, so you can bug her with questions about it. I'll show a quick peek at what the script actually does. This script goes in over the Azure API and as well as the Consul API and pulls out the different components that are needed to join nodes to that cluster. So we pull out things like the certificate, we pull out things like the gossip key, All of these things are how we ensure that a cluster is safe and secure. So we bring these in and we add these to whatever platform we're going to bring in. So in the case of the virtual machines, I added those as part of the actual configuration for Consul to join into the cluster. We also create out our configuration file. I had a slight modification to this for my use case. So what I'll do is I will go ahead and cat out that configuration file, and we can step through a little bit about what's going on in here. We're connecting into my Azure data center. We've got our gossip key, which is part of our encryption, right? It's how we encrypt the traffic between actual server nodes and the agent nodes. We've got a specific TLS settings in place, which use the CA cert that we pull out thanks to Arena's script. We have a couple of steps around what nodes we're going to join or what actual environment we're going to join. So this is the internal Azure IP or internal Azure address for our Consul cluster. And we can see that we're joining it as a client. We're setting it to inject, connect. Jono touched on this in his presentation. This is how we make those sidecars pop up. We have Envoy run alongside the workloads. So this actually sets that up to inject that sidecar into every pod that deploys. And then we have some sync catalog set up true to really just mostly just show that we're actually bringing the service catalog into Consul. So like both Jono and Nicole did, I'm going to use Helm to install. I'm going to do Helm install. I'm actually not going to use that one. I'm going to use this. So this is going to fire off our deployment. We'll give it a couple seconds to get started. Cube. Oops, typing's hard. Git pods A, and we'll do a little follow action. Oops, sorry, not follow, watch. Now that came up really fast because I was testing this already. So this wasn't there before. Should have shown that already, but it wasn't there before. It is now. If we switch back into our console, we can see we've got a couple new agents in place. These are our AKS agents that live inside of that cluster. So this cluster is up and running now. It's joined to Consul. So it is now that it's about halfway to the end state of that diagram I showed previously. At this point, we've joined AKS. It's part of the service mesh. So workloads that deploy are now going to have that sidecar injected, and the other things inside of our service mesh can automatically talk, which means that if we look at the services view, workloads that we deploy in Nomad can talk into that service mesh. Workloads we deploy as VMs can talk into that service mesh. These are part of what we like to call a global service mesh. These are multi-platform runtimes that are able to talk amongst each other over those Envoy proxies. Just to touch real quick on intentions, Jono touched on this already. I have a default deny in place. I've got some pre-existing rules in place to support my connectivity into the environment. And we're going to go ahead and deploy our application now. Before we do that, we'll take a quick look at the actual configuration. Jono, again, did a great job of stepping through this. I want to touch on a few specific things in my configuration just so we can touch on why they're there. On each of my pods, I have connect, inject, true. This is enforcing that we're going to inject connect every time. I've got a couple of annotations around the connectivity we expect. So I've got inject true. I'm setting a service meta version of V2. Remember this is important for later. So just keep that in mind. I'm not going to dive into what that is yet. I'm setting the service port for HTTP. And then I'm also configuring some upstream connectivity. So I'm saying that this pod can talk to the database and this pod can talk out to the front end if I want it to. And then again, same thing goes for my front end, setting it up so that it can have connect, inject, true, what port it's operating on, what actual upstream it's going to connect to. So this is going to connect to our API service. And again, keep in mind this actual V2 for the service meta version. This is going to be important in a little bit. So let's go ahead and do a kube control, apply F for our demo application. And we'll see that start to spin off. And instead of watching the pods this time, we're going to watch for the load balancer to kick in. So it's going to take a little while. Azure takes a little bit to spin up its load balancer. But if we switch back, wow, that actually happened a lot faster than expected. If we switch back into services, we can see it coming to life. Now, I did something very specific in here because I was kind of on a time constrained demo. What I did was I set up this application to register into my existing service definitions. So now if we go into front end, we can see we have two different definitions of what front end is at this point. We've got the front end VM that I named VM, so we would know the difference. But then we've also got app front end, which is living inside of that AKS cluster. So these are two different instantiations of that app front end. And that applies to be transparent, API tier as well. I intentionally didn't do this with the data. I wanted to be able to show kind of a separate database. It would be very easy for me to combine that and do the same kind of flow with that. It looks a little kludgy in this. It was intentional to be separated out. All right, so let's take a look now at that load balancer and see if we actually have connectivity into it. There we go. So we can see this looks a little bit different. We're not going to wait for it. I'm actually connected really fast. This is a little bit of a cleaner interface, right? It's a little lighter. We've got the color logos. Things look good. And right now, what we're doing is we have two different applications inside of our service mesh. We peered our VNets. Like, that's an easy thing to solve, but that's not really the activity over IP and port, right? So .1 rules that span for every permeation of that config, dramatically reducing the amount of firewall rules that are in play here. And we start to move into a true. So now we're saying anything that lives in communication, we're taking this up a level and saying, you have an application and you expect connectivity to a remote point. Let's allow that connectivity as long as it's consistently defined. So every time we add things to this front end service definition, that intention is going to automatically bring it in and allow it to be part of that communication path. So we've got our communications kind of established here, but I want to get back to our previous talk around what I was saying around, like, it'd be trivial to move applications and sound to communicate between the two, but that's not really like the heart that I hinted at earlier. What people care about is migration. People care about how I can take systems running in legacy VMs or traditional VMs. Legacy gets kind of a bad connotation to it. I don't think legacy is a bad thing necessarily. It's just the thing you had before. How do I take workloads that live in that environment and be able to migrate them into a Kubernetes environment? And how can I quickly switch those back and forth? How can I do things like canary testing, where I allow 10% of traffic to go into that cluster, bump that up to 50%, and then eventually fail it completely? And we can do this by bringing in, since we're operating in a global mesh and we have these platforms all communicating over the same mesh, the same Envoy proxy, so on and so forth, we can use something called layer 7 routing to allow us to do this trick. It's not really a trick so much as a capability. So real quick, I'm going to head into our consul.io website. I'm going to hit our docs, and I'm going to hit this connect section here. And if you look in layer 7 traffic management, you've got a ton of documentation here on how to configure this. What I would say is hit the learn guides. The learn guides have a really, really good L7 like training around how to actually consume this capability. What we're going to do is we're going to show live how we can start to flip this service from running inside of VMs and having it reach our destination inside of VMs to actually reaching inside of Kubernetes. And we'll do some tricks along the way to flip that back and forth and show how we can change this around. So in order to do this, we have to be a little bit aware of the architecture we're working with here. We have our Kubernetes environment here, and we have our virtual machine environment here. We know that's running on the VMs. So let's go ahead and switch into command line, and we're going to start to make a few changes. Now I'm on a VM here that's aptly titled HCS client VMs or client 04. This is an Nginx server. If I'm honest, you know, to throw shout out to Eric in the background from F5. This is just an Nginx server, right? We are proxying communication into our service mesh and allowing communication between points. And what we're going to do is we're going to start to load up some of these policies. So if I do an ls here and I cat out some of these files, you can see we're defining aspects of our service defaults, our service resolvers, and finally our service splitters. So our service defaults tell Consul what type of service this is. In this case, we know our front end is an HTTP service. So what we're going to do is we're going to write the configuration. This can be done via API as well. This can be done via a number of different ways. I'm doing it from the command line for a reason. We're going to do Consul config write. And we're going to step through and do each of these. And then I'll back out and explain what's going on here. Make sure I backed out one of these changes. I did, cool. That would have been embarrassing. All right, so let's start from the top. I talked a little bit about what this is. This is defining out that our front end is an HTTP service. By default, things come in as TCP services. We're telling Envoy that this is an HTTP service, so we can do layer 7 routing against it. If I now cat2, I told you earlier to remember that v1 thing and that v2 thing inside of the Kubernetes manifest. What I've done here is I've set up a service resolver for my front end service to say that I have 2 versions of this service that are in play. Look at the version meta tag inside of each of those individual registered services, and give them a label, right? So in this case, v1 maps to version v1, v2 maps to version v2. Pretty straightforward. And the real magic happens in step 3, where we say, we're gonna actually split this traffic between environments, right? We're gonna say, in this case, all the weight goes to service 1, none of it's going to service 2 at this point. So now, if I go into my application, it's going to stay going to VM because VM is the v1 is the VM environment. So there's no real change to the routability of this at this point. What's really clean is if we go into our service now and we hit that front end service, we can hit this routing tab and we can see a visual representation on how we're splitting this traffic out. And there's a lot of work going in to improve the visibility in here. I can't really dive into what that is, but there is definitely some work going into how we see this and that you should stay tuned for. But you can see I have it set for 100% of the traffic to go to that v1 front end. Let's switch this now. Now, typically in a longer demo, if I had more time, we do this canary style and we'd send a very small amount of traffic to the v2 and monitor to make sure things were good. But it's a Wednesday, so we're gonna go YOLO and we're just gonna change it all. All right, so we're gonna vim into 3, which is our service splitter, right? So we're splitting services. And we're gonna go ahead and flip this from 100 to 0, and we'll go 100 there. And we're gonna write this again. So now if we head back into Consul, I don't think we need to refresh, but I don't want to be embarrassed by it not showing up right. So I'm going to refresh anyways. We're now sending all of our traffic down to the v2 service. And if we hit this, we can see that front end is now pointed at Kubernetes. So we've effectively migrated in a very short and kind of cheeky way. We've migrated the way the service routes from being one hitting the VMs to now routing into the Kubernetes cluster. That's your VM migration, VM to Kubernetes migration. Obviously, there's a lot of app work. I don't want to trivialize that enterprises are still figuring out how we're going to take these monstrous previous applications and move them into the model. But assuming you've solved that, this is a really simple way to transparently move this into that Kubernetes environment. So we've done that now. We've moved to the front end. But what about the API tier? And if we go in here, we're still on the VM-based database, right? So we're still using the VM API tier, which means that the way this is routing is Kubernetes is going out and hitting it, looking at Consul and saying, hey, where can I send this traffic? I'm going to send this traffic to our VM API tier, which is, just for the sake of conversation, it's HCS client 02. But now let's do the same thing for the API tier, because as we're breaking this into a microservices approach, Peter is hosting this call and Jono and Nicole are also helping out. I might own the front end. Peter might own the API tier and might be doing all of the dev work there. And Jono and Nicole might split database duties, right? So each one of these could be broken up in that way. So I'm going to break it up in the same way when I look at how I split up these services inside of my routing. So let's go in and add this configuration in for the API tier as well. So just to do the magic show trick, if I go and look at my API service, I look at routing, I have no splitters set up. I have nothing special in here. This is all default at this point. So let's go back in and let's do Consul config write 4, 5, and 6. And just to, again, show all the details. Same thing we did before, just with an API service instead of a front end. Not going to dive into how it's actually working again, but I actually didn't switch back this one. So before you all get to see that, I'm going to fix that to go back to what it should have been at the start of this demo. So I'll reconfigure that one. So let's switch back in. And we can see this is updated with our new splitter. Everything's going to V1. V1 is the VM. V2 is the API inside of Kubernetes. So if I go in here and look now and I refresh, we're still running on the exact way we were running before, right? Our API connectivity locks in immediately. Our database takes a few minutes to pick up, but it does eventually. We've got our pretty logos, things are good. Let's go ahead and flip this now, just like we did before, but instead, let's do the canary play. Let's set this as a 50-50 split and do some refreshes on the browser and show how we're splitting this traffic between the two. So we'll go in. Switch this to 50-50. Write our config again. Switch back into console. Confirm that we are in fact 50-50 splitting. We'll hit this API tier. Now, because this was a new deployment, normally I would have spent the time to have the backend say, what database am I on, the Kubernetes one? It's just gonna be blank. So it's blank. Let's make this interesting. We'll go, what database am I on? We'll get kind of snarky. Oops, we'll go Kubernetes based one. Cool. Maybe. There we go. Because we're cloud native now. There we go. So what's happening is we're splitting the traffic. So it's hitting, like it's actually injecting into both of the databases. So unfortunately, like if the timing had been a little bit better there, it would have gone to the right one, but we're splitting between the two. So what happens is when I do that post, it fires off and actually posted into both databases. So now we have that entry in both, which kind of messes that up a little bit. So again, what we can do now is so it actually injected into the VM-based database and the Kubernetes one is still empty. But we can actually fix that and show how this can actually work the right way by going over and flipping everything into the Kubernetes data or the Kubernetes based API tier instead. The Kubernetes API tier is coded to use the actual API tier inside of Kubernetes. So it is going to be blank 100% of the time now. So we'll configure it. So now we failed all traffic over. And if we consistently refresh now, it's always going to be the blank one. So now we'll go, what database am I on? And we'll go the Kubernetes based one. I'll do a little self snark there. So we've now effectively migrated 2 levels of our API tier, or 2 levels of our application tier from being front end on VM and API tier on VM to both being in Kubernetes, talking to a database inside of Kubernetes at this point. I liked the dark mode personally more. So as I wrap up this demo, I'm going to flip the front end back and show how the front end can go back to running on VM while the API tier is still talking to the the front end is talking to the API tier inside of Kubernetes and the database inside of Kubernetes. So as we wrap up, we'll go in and do a vim again on number 3. We'll switch this back so that our VM is running front and center. We'll drop that down to a 0. Should have just done it this way instead. We'll confirm in console that we flipped this back as we expected it to. Routing, everything back on VM. It's empty there, looking good. We'll refresh. We're back on dark mode. Wait to connect, awesome. And we're still running on the Kubernetes cluster. So we're wrapping up now. This is the rollout portion. you showed that what I've shown here is that we can easily take HCS and have it operate in a multi-platform model. It becomes this consistent service mesh and this consistent networking plane that lives inside of Azure, which is really interesting because when you think about real like enterprise environments, workloads are mixed. People are still using virtual machines for a lot of things. People are using Kubernetes for a growing amount of things. And being able to have a consistent networking plane between those that lets you split services between, shift traffic between those environments, do those migrations is something that people actually need. And you don't want to have to worry about the underlying infrastructure of Consul as part of that. We can manage that for you and let you actually get back to operating the environment, which is doing that traffic shifting and that migration. That's the work that matters. Standing up 5 Consul servers, 10 Consul servers, that's work that's important, but it's not the work that matters to delivering connectivity and applications. That's ultimately like one of the big things that I hope people take away about service mesh. It's not about being a catchy phrase. It's about solving a problem that we actually have. And that's how we wire applications together in this mixed platform world. And things like Consul Service Mesh does that. It does it really, really well. I want to highlight this on the screen right now. If you hit this with your QR scanner that Jono talked about earlier, I think we've used it a couple times now, this is going to dump you to a bunch of really useful resources. A lot of the Learn guides that our Learn team spends a ton of time working on and perfecting out to make sure that customers are actually able to come in and use our products. Check those out. It's really worth it. The new Service Mesh track is great. Spend some time in there learning how Service Mesh works. Check out the Layer 7 observability stuff. Check out the Kubernetes guides. It's really good stuff. Spend some time in there. A couple other things just to call out on this. I got the link for the Consul Kubernetes track. If you hit that QR scanner, you'll get all of this anyways, as well as some additional ones. These are just a couple I wanted to call out. Consul Helm chart. We have a great team focused on building this Helm chart inside. They're a great team to work with. Again, Irina's on the call. Make sure you hit her with questions. She's brilliant and is going to be able to help out a lot here. We have the Helm chart reference. This is going to take you through how to configure that Helm chart kind of end to end, all of the options that exist. We're going to talk, we have the Learn tracks here as well for the different tracks that matter, things like Kubernetes, as well as the Service Mesh specific one that is a newly revamped one. With that being said, thanks for the time. I appreciate you guys sitting through my presentation, and I'm going to hand this back over to Peter. Peter, take it away, buddy.
Thanks, Cody. So thank you all so much. We're right there. We're going to the next session. So Cody mentioned that now that you have this great service mesh up and running, you have a whole bunch of services that are talking to each other. You probably want to have a little bit of access controls over those. So we invited Matt Keeler from our Consul engineering team to talk a little bit about access controls and how you can manage them and set them up.
Thanks, Peter. Like Peter said, my name is Matt Keeler. I'm a software engineer on the Consul team here at HashiCorp. And today I want to talk with you a little bit about how to manage ACL permissions in Consul. This is going to be focused a lot on OSS and just general usage, but then the second part of this is going to be focused on using ACLs with namespaces and delegation, things like that. There we go. All right, so before we can get into the bulk of this, there are prerequisites that we should put out there as things that you must do before you can actually have a secure system and start using tokens. So the first one of these is you need to have enabled surf encryption or gossip encryption so that other unauthorized agents cannot just join your cluster out of the blue. Second thing that you need to do is enable TLS encryption. This is include both RPCs, communications between Consul clients and Consul servers, as well as TLS for the HTTPS server. Both of these are necessary so that when you are using your tokens and things to access the API, that they won't be transmitted plain text over your network and potentially sniffed and stolen. So, and the last prerequisite we have here is that besides just enabling ACLs, you should always be in a default deny mode. You should not use default allow. And also for the purposes of the demos, you will need to have bootstrapped your master token, whether it's via the CLI, API, or in one of the configuration files. And so also for setting up all of this, I'll have links more towards the end, but all of our Learn resources, there's a guide for each one of these. All right, so Consul has many Apple resources. There are 4 that we're going to talk about and focus on in this demo. There's 2 others related to auth methods and binding rules, which are essentially how to take an external identity and get these resources attached to it. I'm not going to focus on those. So starting here, the first resource that we're going to deal with is the token itself. And this is really just a set of API keys that is associated with one or more policies, roles, and service identities. It has a secret portion of it, has an accessor ID. And whenever you make a request to Consul's APIs, you have to specify that secret ID as a bearer token to authorize your request. Next, we have the policy, which is a rule set. So all the permissions when you grant or deny access would be in a policy. Potentially you're granting permissions on Consul's KV store or in service discovery permissions, things of that nature. Ideally, these rules should be all related within a singular policy and scoped to, I think, one logical operation. And so a good example of that logical operation could be if you're using Consul's distributed locking functionality, then you would need permissions in both the KV and session. But they're kind of, in order to use that functionality, it's like that one operation you're doing. So you group those into a singular policy. Next, we have the role, which is just a grouping roll-up of a bunch of policies and service identities. And I like to think of these as aligned more with a user or a service, some sort of entity that needs to perform multiple types of operations. So you would want to have a role for it and then assign multiple policies, one for each one of those operations to the role. And lastly, and we're not going to cover it too much in the demos, but there's a service identity, which is just a synthetic policy that grants some predefined permissions, which is the ability to register and manage the service that's defined by the name of that service identity, a sidecar proxy for it, for your service mesh, and it also grants general service discovery permissions. All right, so with that, we're going to go direct into a demo. So in this demo, we're going to start out pretty small. We're going to start, and I'll show you over here. We're going to deploy a web service, and this is, for the time being, could be something like a static website, but we want to be able to register this service. And so it needs its own tokens, and we're going to set that up. And eventually, over the course of this demo, we're going to evolve this into multiple services that are going to need to communicate with each other, perform service discovery, things of that nature. But we're going to start small and work our way there. So over here in the terminal, I have deployed 3 instances of the same service, and they're all currently getting permission denied when attempting to register themselves. So the first thing we need to do is go and create some policies that allow us to have access. So go in here, we'll call this manage web, because I want to be able to manage this web service. I need to grant write access on that service name. And even though I mentioned that a role is a great way to roll up permissions for a service, I'm going to pretend for the time being that I don't know about roles. And I'm just going to create tokens linked directly to these policies. And over the course of the demo, we'll show you why that was not a great choice. And also, I have 3 service instances. So I'm going to duplicate this token a few times because I don't want to share my tokens. Back over here in the terminal, I have some scripting around to import these tokens into my shell so that when I redeploy, the tokens I just created and the policies that are associated with are now granting me the permissions necessary to do what I wanted to do. And we can also verify that they were registered over in the Consul UI. All right, so that's great. If we have our static website, whatever it is, and we can now register the service and things will be able to find it. But we want to do more than that, right? So now I'm going to be deploying a little bit more complex configuration where now instead of having one service, we have a web service, an API service, and a database service. And in this scenario, our web service is going to want to use both the API and database services. And our the API service itself will also want to use the database service. For the time being, they're still getting permission denied errors because we haven't granted them any permissions or any tokens. And I could do that same thing through the UI again, but instead I have scripted this using our CLI and have got it all set up so that they will, I did the exact same thing. So the script there that I just ran created another policy for managing the API, one for managing the database. And finally, it created a whole bunch of tokens. And so now all the service registrations are happy, but that doesn't really help us because they can't do anything with each other. So I'm gonna enable them to start discovering each other so that they can figure out how to route to one another, right? They need to find each other's IPs. And when I redeploy this, take a second, there we go. You can see here that all the service registrations are successful. There's no permissions denied errors. We have the API service, which is attempting to do service discovery on the database service. We mentioned it would. It's not finding any. It has a count of 0, even though there's 3 database service instances available. Our web service, similarly, is also looking for both the API and DB service and again, coming up with nothing. And the reason why is because it doesn't have permissions to it. Instead of permission denied errors, many of the Consul APIs that list things, such as service instances, will filter the result set. So you will end up seeing nothing, even though the reason why is it's you don't have permissions to see it. So let's go ahead and fix that. And again, I mentioned that you should try and scope your policies to sort of logical operations, but we'll pretend that I don't know about that for just a moment. And I'm going to assign all of these permissions that our web service needs right in the one policy that it's already using. So I'm granting it read permissions on that database service so that it can discover that, read permissions on the API service. And then there's also this node rule, which is necessary so that the services, when it finds them, it can read its node information as well. And I will go ahead and save that. And pretty soon, yep, there it is. Our web service now is discovering the API service and database service as we wanted. So that's great, but now we need to do the same thing for the API service. And we could go in here and just copy paste some rules, the same ones we used before, maybe get rid of the one that has it read itself. But we don't want to do that because we're starting to get a lot of duplication here. And if it's just a couple policies that you have duplication in, maybe it's not that big of a management burden for you. But if you have 100 services that all need to access your database service and find it, then managing that over time would become pretty difficult. So I'm going to back out this from this policy, and we're going to do it the right way now. So I'm going to create a few different policies, and it's going to create the first one here, which is allows the node permissions. Second one to be able to discover the API service. And then finally, the third one is to be able to discover the database service. Here we go. So at this point, everything that didn't actually affect anything. All we did was create some policies. So we also before we didn't bother creating a role, and this is why that's problematic. We can go in here and I can attach a bunch more policies, all those policies necessary to one of these web service tokens, and it will work. As you can see over here, it already changed. Now it's able to discover those instances that it wanted, but that didn't affect these other 2 web tokens. If I had 10 or 20 of these, you don't want to go and have to edit 20 tokens just to do that. And this is where a role would have been the proper way to do this. And so we'll fix this up. So I'll create a role. We'll call it service web because this is the role for what it means to be a web service. We're going to grant it all those policies that we just created, including the one that allows it to manage its own service registration. And unfortunately, because we didn't do that role before, we have to go in and assign it to all these tokens after the fact. I would say in general, if you find yourself duplicating or cloning tokens or just creating identical ones, not using the cloning functionality, you probably want to ensure that you're using a role. That way, when you add policies or your permissions evolve over time, it's a lot easier to just have it apply to all of your tokens. And so, okay, we'll fix up these other two. And I'm also not removing the duplicate policy just because it saved me a couple clicks right now. Internally, when Consul resolves these tokens, it will dedupe all the policies, so you don't have to worry about that. All right, so all my web services are now fine. They're discovering everything as desired, and we want to do the same thing for both the API and DB services. Again, I have a little automation set up. It's using our Consul CLI to do the exact same thing. If I refresh over here, you can see that our API tokens and our DB tokens were all converted over to using roles. And now everything's happy. Everything that wants to discover everyone else, that's all good. But now we're going to go even further. So now, in this scenario, we want a little extra coordination between the things that use our DB service and the DB service itself. So maybe in this case, the database service needs to advertise in the Consul KV store, like a particular protocol that it wants to be communicated with. And then the other services, the API and web service, need to look at that KV entry, figure out what protocol, and it's part of their discovery of that service. So at this point, we have our permission denied errors back. So the API and web services are failing to read the KV data at this DB protocol KV path. And here's one. The DB service is failing to write it. So because we have these finer grained policies, we can go back and fix this up real quick. And the first thing we need to do is grant our database service the permission to write that KV path so that it can advertise what protocol it wants to be communicated with over. And pretty immediately, that should, yep, there it is. Here it is. The database services are now writing it. They're not getting permission denied. We didn't have to modify their role. We didn't have to modify their token. And the reason why it was a good spot to put that is because conceptually, being able to manage that database service, part of that is involving setting up this advertisement. So conceptually, it makes good sense to put it with that. Similarly, all of the other services, our API and web, it's part of discovery to be able to figure out what protocol this should be using. So a good place to stick that is in our discover DB policy. And then we'll go ahead and save it, and everything should, yep, everything's good now. So we can see that we're reading the value out and everything is happening perfectly. And so hopefully what I've been able to show here with this little demo is the value of roles and finer grained policies and how manage them in this way. And this was on a very small scale, but at a much larger scale, when you have more service instances and when you have many more types of services and that use common functionality, being able to make fewer edits to propagate all the permissions that you need to where they are needed. If you do it in this manner, it can save you a lot of editing of many things. And so go back over to some slides. So next, we want to talk about namespaces and ACLs and how they interact with each other. So there's two big features that I like when they're combined. And the first is with delegation of app management. So if you are using Consul Enterprise and you now have the ability to create another token and give it out to another user, or maybe you have automation to do this, so maybe it's another service, and grant them the ability to create policies, roles, and tokens within their own namespace. and restrictions are in place to keep them from targeting other namespaces. So they can have their own little view of the world and manage ACLs themselves. So if you're in a large organization and you don't want to have your one security team manage ACLs for every one of your application teams, this would be a great feature for you. The second cool feature is the ability to infer a namespace for a request from the Apple token being used. And so what normally happens is when you make a request when in a Consul cluster, when ACLs are not enabled, it will just default to the default namespace. But when you have ACLs enabled, it will default the namespace to the token's namespace. And to show you some of these features, we're going to go to another demo. Same cluster here, but I have reset my demo environment. We're going to do this. And for this demo, it's going to be mostly similar to the previous one, except all these services are going to be namespaced. The web service is going to go into NS1, the DB service or the API service in NS2, and then the DB service in NS3. All right, so deploy the web service again. You can see it's getting permission denied in NS1 this time. And the first thing we need to do is actually create a namespace. It's pretty simple. You can do it through the UI, you can do it through the CLI or API. One thing to note here is that each namespace can have some default roles and policies associated with it. And when you set these up, every token in that namespace will automatically get these permissions. So if you wanted to grant service discovery to everyone, you could do it here. But for the time being, we're going to leave these blank and come back to that in a moment. All right. So now that we have our NS1 namespace, we don't want to have to manage that namespace. We want someone else to do it. And I'm currently using the master token. I have permissions in multiple namespaces because of being that master admin, if you will. But I want someone else to handle this. So if we go over to the ACL specific to this namespace, you see there's no tokens, there's no roles there. But when we created it, it injected this namespace management policy for us, which grants us pretty much every permission that is available in that namespace, similar to the global management policy that you'd find in the default namespace, except it's slightly more limited because some permissions cannot be granted within a namespace, such as operator permissions or node right. So we're going to delegate our Apple management for this namespace to someone else. And it's pretty simple. You just create a token with that namespace management policy. And so I want to be that person, so I'm going to use this token. And you'll see it'll change my UI a bit. I no longer have permissions on any other namespace, so there's no drop down. I can't see the default namespace, and I won't be able to see the other namespaces as we create them. And so now we'll do sort of the same thing we did before, except within a namespace. Create this manage web policy and save it. So one other thing to note here is that this policy is basically this policy. Get the indentation right. And so you don't have to put this in there because the policy exists within the namespace. Consul can infer this extra namespace block for you and will just act like you wrapped it in there, but it's fine if you put it in there or not. All right, so now that we have that, let's create our role because we learned from last time that would be a good thing to do. And for now, we're just adding the service discovery permissions, or not the service registration permissions. And we need to create a few tokens. And again, I'm using this delegated management token, so I don't have to, so my super admin, if you will, doesn't need to interact with this. I can do it self-serve. I'll duplicate it a few times. And things are good. Except now I'm trying to do service discovery and can't. for the same reasons as we had before, except it'll be slightly different solution. This little script I have, it went ahead and created the other namespaces and other tokens just like I did right now, including with the roles involved. And I'm going to deploy all of those. And so now cross namespace permissions in Consul are the purview of the super administrator who has a token in the default namespace. And just to show you that, me still being this delegated admin, I'm going to try and create a policy where I would target API service in namespace 2. And it's going to tell me that it can't do it. And that's because we're restricting it. You cannot target any namespace outside of your namespace. So I'm in NS1, I cannot target NS2. And that way we're preventing leaking of permissions. So then how do we actually do this is the question. Let me stop using this token and go back to my master token. As you can see, I have my permissions back. We created both NS1, NS2, and NS3 namespaces. All right, so like I mentioned, we have to do this, we have to grant those same permissions somehow. And the solution is those default policies and roles that you can attach to an individual namespace. So I'm going to create the few policies similar to what we created before, except these have to target a specific namespace. Otherwise, they would be implicitly scoped to being in the default namespace. So I created one to discover the API in namespace 2. We're going to create a similar one to discover nodes. At this one, I'm just going to grant it blanket permissions across all namespaces. And then finally, we need the same permissions in, well, similar permissions on the DB service in namespace 3. All right. So at this point, we still don't have the permissions. They're still not working. And we need to go back over to manage our namespace and grant these permissions as defaults. So namespace 1 is where we have our web service, so it needs permissions on both. Namespace 2 just needs the ability to discover nodes and the database service. And as soon as we apply these, all those service discovery counts go back up, and everything's good. So the few things tried to show here are how to set up cross namespace permissions, and that was with the default roles and policies that are attached to the namespace configuration itself. How to delegate ACL administration, which is to just give a token ACL write permissions in a particular namespace. And so the last little bit to show is an example of that namespace inference based off tokens. So going over here, I'm going to pick one of those web tokens from the NS1 namespace. If I was to run Consul catalog services with that token, it's going to show me just the web service. And that's, I haven't specified a namespace in any form, whether it be an environment variable, which isn't set, or in the command line, but it's defaulting that to NS1 for me. It's not the default namespace because its ACLs are enabled. I can still, because I have permissions, target a different namespace, but that's specifically if I want to care about other namespaces. So in this manner, like whether you're using the API or the CLI, we can do that defaulting for you. So some app developers, maybe they don't need cross namespace access or permission, so they don't have to necessarily care that they're in a namespace all the time, and they don't have to add that to their requests. All right, let's see. So this was the same QR code that Cody put up just a few minutes ago. It will link out to a bunch of different resources on the Learn websites. And just a couple conclusions to wrap up. I've automated a lot of those demos, and as your infrastructure scales and as your ACL needs scale up, you will probably want to do the same. We have our CLI to help you out if you like scripting things, our HTTP API, everything that we've done can be done through that API as well. There's other things such as secret engines for Vault and other integrations as well. And so finally, there's a few, and these are all linked in that previous QR code, but there are guides specific to setting up all of these things on the Learn platform as well. And that's it for me. Thanks a lot, and back over to Peter.
Oh, there we go. Got to unmute first. Okay. Thank you all so much. At this point, we're going to switch over to our live panelist Q&A. Before we get started, a couple of things. I just want to thank all of our speakers very, very much for taking the time today. We know that this is a long event, and we appreciate those of you who are able to stay on for the entirety of the event. And hopefully we can answer some questions. Hopefully you got some great information. On the slide that I'm showing as well, that QR code that we've shown a number of times, we showed you a lot of things today, and we recognize that. Hopefully there's some useful information. We have a number of different resource guides that allow you to be able to see a lot of what you saw today in a step-by-step format. So this is a really good way for you to be able to get started using Consul. We hope that afterwards you give it a try if you aren't already doing so yourself. And then if you run into questions, feel free to always reach out to us. So at this point, I'll invite my panelists back on. So you can go ahead and join here. All right. Hey, Jono. Nicole. There's Matt. All right. So Matt, I know you were just talking, but we did have a couple questions that came up. So I'll start off with you. One of the questions that came up is, can you leverage token creations from Vault for Consul as part of the ACL process? Or maybe talk a little bit about how you would use Consul and Vault together.
Right. So Vault, it does have the secrets engine, which if you're not using Consul as a storage backend for Vault, you can use it and it will mint tokens and for you. It doesn't automatically create the policies and roles for you, but so when you're setting up Vault, you essentially give a Vault role and you tell it, I want this role to mint tokens with these predefined list of policies and roles. And so it can handle that for you and handle the life cycle of those tokens.
Awesome. Thank you. Jono, back on your presentation, one of the things that you showed was your values.yaml file. So did you have to merge in your custom values with that file in order to get it to do what you wanted to for the demo?
So for that particular instance, all I did is I had the separate file and it overlays on top of the existing one that comes with the Helm chart. So you can either pull that values file from the Helm chart, edit it, or maintain your own separate from the Helm chart and apply it, and it works together.
Thank you. Cody, so one of the questions that came up during your session was talking about a best practice around deploying a sidecar as another VM. Do you recommend that, or what do you think is the right approach for that?
Generally, I think it is, right? I mean, when you look at the Kubernetes model, these run as sidecars for the pods. So really, they live next to each other anyways, in like a Kubernetes environment where sidecars are much more common. I think that the perceived benefits of separating these out into different machines is probably not going to be realized as much as the convenience and the capability to keep your application kind of co-located in one system. I would say best practice on the VM side would likely be to fold those in, to have Envoy running inside. And in my case, I run it as like a system D job, right? So I have the binary down for Envoy. I have a job running. I can push that out to new nodes using like any config management tool like a Puppet or a Chef or an Ansible to create that job and have that running alongside. And it just bolts right onto the service. So when the service registers, that Envoy sidecar is registering against that service on the same node.
Awesome, thank you.
No auto-tune this time?
No auto-tune this time. Matt, so one of the questions that came up also, and I know this is kind of what you covered in your whole session, but just maybe real quickly, just as like a recap, what were some of the best practices that you mentioned for managing ACL tokens? So maybe what to do, how to retire and rotate them, things like that.
So starting from the policy level on up, like it comes, like the first good thing is properly scoping your policies, right? You don't want to be duplicating stuff, permissions all over the place. And then you have so many things that need to use the same permissions, you end up having to make tons of edits to have that permission apply, just because you deployed a new version of a service which is slightly different and requires modified permissions. The second big thing is don't like make the same token over and over again with the same policies. You really want to have that intermediary role in there as the place to roll up all those other policies. If not, you end up with a lot more edits. So one of the key things is trying to find the best place to link things in, whether it be at the role level or granting permissions in the policies, to minimize the number of places that you have to change when you inevitably evolve your infrastructure, right? And so as far as tokens, use automation. Don't do what I did and do it all through the UI or CLI. It's good for like a quick, it's good for a demo to show like actually how you would go through and create these things in the UI. But beyond like a small scale, you're really going to want to automate all of this. So go look at our API docs and or the Vault secret engine, or even the Terraform provider has a way to manage these for you as well if you wanted to do it in like HCL as code.
Awesome. Cody, question for you. So you talked a little bit around HCS versus some of the other demos, which were really focusing more on like either Consul open source, or in Matt's case, you showed like Consul enterprise. Do you think you could walk through a little bit of maybe some of the benefits of using like HCS? Like what are some of the operational headaches that you might run into if you're trying to manage your cluster on your own?
Yeah, so when I look at like managing a cluster on my own, let's take a step back and let's talk about how I do this when I'm not using HCS. There's a few layers that I have to account for, right? I have to account for how I'm deploying my server nodes in a consistent manner, right? So I need to have some form of automation around that. Am I going to use Ansible, Chef, and Puppet to push this out to machines as they deploy? Am I going to keep that stuff stored in like Git as a consistent place? Like as far as like configurations go, when I want to scale that out or I want to change the configuration, how am I managing that on the back end? How am I worrying about scale considerations in themselves, throughput, consistency of configuration, drift? These are all things that are like operational problems that people have to solve. In my case, when I do it, I tend to wrap this all into like the most duct tapey Packer build that I can for my server image, and then I deploy out a bunch of server nodes, and I just kind of hope that I don't need to change anything. And then when I do want to change something, I go and I rebuild that Packer image. But this is now something that if I translate this into the enterprise, this is the process that I know how to do, and I have to make sure other people know how to do when a change comes up, right? When I want to change the way the system works or change the configuration. Looking at things like Matt presented, talking about like ACLs, we're going to be bringing ACLs to be kind of a first class state, or not first class, that's not the right word, but like ACLs configured by default in HCS, and as well as like the encryption being configured by default. These are all things that you normally have to account for when you're configuring the environment, but with HCS, it's just there. Right, and that's all operational things that are now offloaded onto HashiCorp's SRE team to manage. When a node stops working, that's not your problem. That's the SRE team's problem to solve. I'm a big fan, like when I was in an enterprise and worked in the enterprise, I was a big fan of technology to let me just get back to doing my job and get it to do the things that mattered. And we have a ton of things layered on often that don't really matter to the things that our customers want us to do. And we have customers like when we're working in the enterprise too, like if I'm in IT, HR might be my customer asking me to get their system up and running. They don't care how many Consul nodes I'm running. They don't care about the time it takes me to scale out Consul. They care about, is their application registered? Is it healthy, reachable? Do they have connectivity? Like, and really, they don't even care about that stuff. They care about going to a web page and it loading up. Like all that backend stuff that happens is stuff that I have to worry about operationally. And taking the pile of work of managing a fleet of infrastructure is something that I'm more than happy to take off my plate. That's not for everybody, right? Some shops have manpower to be able to do that and manage that infrastructure, and that's just part of their operational model. But I think when we look at the majority of these things moving to a managed service model, look at things like database, right? Like there was a time where databases were something that people always were going to hold on to. They would never run a cloud native database. They would never run this in the cloud because they needed to know all of the configurations and manage it end to end. And that like mindset has drastically shifted. People are more than happy to have Amazon throw out an RDS database or run it in Azure and run a managed database offering there, because it's unnecessary overhead. HCS is just the next logical progression of moving things to a more managed service model.
Awesome, thank you. So John or Nicole, I'll throw this out to either one of you. Can kind of split between, came in right between your two sessions. Could either of you walk a little bit through mesh gateways and just kind of explain what they are and how they're used? Just because I think there was some question about connecting multiple Consul clusters. So Nicole, I see you raise your hand, so I'll let you go through.
Yeah, so I'll take this one. Right now, that process is a little convoluted. Coming out soon, we will have WAN federation, which will make it possible for you to actually federate two Consul clusters together through the mesh gateways and only have to expose the mesh gateways through the internet. And so that process makes that a lot easier. Right now, you either have to find a way to expose the Consul servers to one another so that they can communicate directly, or you have to bridge the networks using VPC peering or something along those lines to make it happen. But with the WAN federation that's coming out, and I believe the next release is the target, that should make this a lot simpler.
Thank you. And that actually feeds good into the next question for you, Matt, which is, are ACLs and TLS mandatory for federating Consul?
Technically, no, they are not. You can set up Consul without ACLs, without TLS. It will work. But as you start to use more of the features, like when you go into using service mesh and intentions, if you don't have ACLs and you don't have TLS enabled, then none of the other stuff is actually getting you any security either. Because if you can make a request to Consul without an ACL token and get that certificate, anyone can. So that certificate is sort of meaningless, right? So if maybe for some service discovery scenarios where you're super firewalled off, locked everything down, and other means, maybe you are okay with running without ACLs and TLS, but I would say in the general case, you probably want it, even though you can set it up without it.
Excellent, thank you. So we'll give it a second here just to see if we have any other questions come in. Again, I just want to point out the slide that we're sharing, the QR code is going to give you resources to a lot of this information that we covered today. It'll help you walk through the different tracks. So make sure you do that. And also as a reminder, we are recording this session. We're going to be breaking it up into each of the different components, adding them as individual resources. So it's going to take us a little bit longer than our normal webinar turnaround time, but we will be making it available to everybody